Some of the members are already doing it and it's really working nicely for them. Okay, chalo, let's get started. So as part of today, we are going to discuss one important technical topic of unit testing. Okay, but if you really see, it's three topics together. So unit testing is not just one independent piece. Unit testing always works along with mocking, and there is one more concept associated with it, code coverage. So always these three things go hand in hand for almost every time. Okay. Now the thing is, why unit testing? What is the need of unit testing? One by one, we need to understand all of these things. So please put your entire attention and we will start with the discussion. Okay. So let's open up a diagram. Let's open up one diagram. So basically, what is the need of unit testing? Then later we will come to what is unit testing. First, let's understand the need of unit testing. Okay. So let's say there is a situation. Currently in the company, there is one developer and there is one tester who is developing. So this guy is developing the feature. Testers are also called as QA, quality analyst. Okay. This guy is testing the feature. And let's say they are doing this in 2025. So some feature is ready, working, and you deploy into production. Okay. And let's assume like 1 year passes by and now it is 2026. As part of this 2026, now let's assume by this time, both the people have left the company. So people keep moving, right? They move to other organizations, they switch jobs. So let's say both the people have left the organization. Okay, both members leave the company to go somewhere else. Okay, and now there are new team members who are working on this project. And now just imagine in 2026, some new feature change came for which you have to update the previous feature. So if here you were doing feature 1, so in 2026, new feature changes came for which you have to update feature F1. And just try to imagine now, both the people who developed it and tested it, they are not there. The only thing which new team members will be able to check is documentation. They will look at Jira tickets. Sometimes in the projects, there will be documentation. People will use some software called as Confluence. It is one of the software, or anywhere. They can use whichever tool. In that, documentation will be there. And they will look at the source code. Means the people who developed the system, they left. And after 1 year, new modification needs to be done by new team members. How will they know what was the old feature? They will do these three things. So they will read Jira tickets, documentations, source code, and then they will try to analyze, okay, what was the feature earlier? And after thorough understanding, they will do new code changes. And there is always this process. Whenever somebody leaves the company, they have to transition their knowledge to other people. So before leaving, while they are serving the notice period, so whenever somebody leaves the company, generally they have to serve some notice period. In many companies in India, they have criteria of around 2 months notice period, and service-based companies also go to 3 months of notice period. Means before really leaving the company, you need to be with the company up to 2 to 3 months. So that is the handover period where you train other people on your responsibility and close whatever tasks you are closing. So that kind of thing will be there. So during this notice period time, you will do training also, okay, to other people about whatever your work was. So despite doing all that, so technically it can be called as KT, knowledge transfer. Knowledge transfer. So basically, whenever new team members are supposed to make modifications to old systems, so they will refer to these multiple sources and they will give their best to understand the system. and then they will do new code changes. That's how it is going to be. Now, still, just imagine, today in 2025, the feature was ready, deployed into production, and live customers are using the feature, are using feature. Now, just imagine, even after all of these practices, there is a question: what if they do something wrong? What if they do something wrong? It's always possible, because manual mistakes can always happen, right? You did all the best that you can. Still, you are changing the code which was developed 1 year ago. What if you don't figure out something and you break the system? So basically what is happening is, when you make new changes in existing code, there is risk that we might break the existing system. This is a very big problem. Okay, so whenever you are making new changes in the system for existing code, you want to modify, there is always this risk that you might break the existing system. What does breaking the existing system mean? It means previously your code was deployed into production, live customers were using it. After you make these new changes and deploy into production, old feature will not behave properly. Live customers will start facing problem, and that is what it means. You are breaking the existing system. Okay, so then what will happen is, these people will raise customer support request. Hey, on so and so date I tried to do like this and it is breaking. 1 month earlier I tried, it was working fine. Can you please check what is going on? So support queries and all those things will happen. Okay, so just try to imagine, as a team, as a technical team, this is a very big problem for us, because requirements will keep changing. Some things of the past might not be relevant after even 6 months. So features might be enhanced also. So the point is, as a technical team, we need to build a system that works, okay, even when the people who developed it are not in the organization. This is what we have to build. Regardless of whoever developed it, the system should always be stable. Okay, when we add new code, we don't break existing system. Okay, so this is what is the need of unit testing. Unit testing helps you to do this thing. Okay, whenever you are writing new code, you are going to be sure that existing system is not breaking. Second, even though the people who develop the system, even if they leave, okay, if they are not in the organization, still the system should be able to take care of it. We should not be dependent on people, because yes, they are going to come and go. That's the journey of IT projects. So we cannot be dependent on one particular person. We need to build these kind of systems. Okay, do you know this interesting thing? Many companies do this. Okay, there are mandatory leaves which people are supposed to take. Mandatory leaves means they say ki, okay, if you don't take these leaves will just disappear. So there will be a deadline. Let's say within 6 months, you are supposed to mandatory take, let's say 15 leaves, or some companies might even give whatever, more or less, let's say 10 to 15 or even 20 leaves. So they will give a deadline. Let's say by December 2025, you need to take these leaves. Means you should not be in office. You have to take it. If you don't take it, this will become zero and you cannot take advantage of those leaves later. These kind of processes are there. Why these processes? For simple thing itself. Okay, the people should not, okay, the system should not get too much dependent on individual team members. That is a very important thing. Just imagine if there are 2-3 people, and if they are not available, the project cannot function, new development cannot happen, testing, debugging cannot happen, production bug fixes cannot happen. That means we have built a very bad system. If you are completely dependent on 2-3 people, let's say my entire project depends upon Tausif. Okay, if Tausif is going on leave, things will become scary. No, such kind of system is a bad system. You cannot be dependent on any one of the team member. We need to make sure it's a team effort. Always think about it, guys. You will succeed when your clients are happy and when your company is happy, when your project is happy. Out of ego, people say, no, no, I became so valuable for the project. But point is, no, that is a wrong system. It is not built in the right manner. The success of the project and everything depends upon success of team, not one person. So always companies will try to make sure we are not getting dependent on one of the team member or two of the team members. So these kind of policies will be there. Okay, take leave, go away for 1 week. Let the rest of the team members do whatever it is. So this will prepare, right? Even if some people, important people, leave the company, go somewhere else, still no problem. The rest of the system is good. So the projects which do these kind of practices, they will never face problem. They're always prepared. And during my initial days of management, this is what I was guided into. Ketosef, you need to build these kind of systems. You need to remove the dependency. You need to keep it decentral so that it keeps working nicely. So this kind of guidance was provided to me also when I was newly starting leading 5-10 member teams. Okay. So the point here is the system cannot be dependent on one or two members, and new changes will always happen, and we might impact the older system. That risk is there. So we want to protect from damage. So what is the need of unit testing? As a technical team, we need to build a system that works, okay, even when the people who developed it are not in the organization. Second, when we are writing new code, we don't break existing system. Okay, so this is the basic need of unit testing in the system. If you do unit testing, automatically these things will be taken care of. Okay, how exactly that happens? This is interesting. Chalo, let's understand that part. Now we are getting into what is unit testing. First, we discussed why it is really required, and these are powerful things. Next, what exactly is unit testing? So how exactly that works? What exactly is unit testing? Let's check on that. Let's say currently you are a developer. You developed a class. In the current project, we developed so much of functional classes, right? So many functional classes. Let's say one of the important class where business logic is there, we say payment service IMPL, right? In this class, core business logic, important business logic of the system is available. Now, let's say you have developed some method 1 year, method 2 year. Okay, what unit testing says? Okay, along with writing the functional code, you need to do additional coding also. Nothing but this is a functional class for you. Along with functional class, you will be doing one more additional coding, and just name that class as test. So whatever is your functional class, you will create a test class for that. And this behaves as your unit test class. Okay. And what are you supposed to do in this unit test class? Your basic aim here is to test, okay, to write code which verifies and protects code in payment service IMPL. This is what is unit testing basically. So along with your functionality, you need to do now more coding. You will be writing new code called as whatever is your class name followed by that test. And this is your unit test code. And here you will be writing code which verifies and protect your functional code. So if you want to really put unit testing in a nice manner, unit testing, okay, code protects code. Nothing but your unit testing code will protect your functional code. So this is how it is going to be there. Okay, how it works and all, we will get into details one by one. But basically, just imagine what is going to be the journey. In the year 2025, let's imagine, in the year 2025, whoever developer has written this functionality, same developer is expected to write unit testing functionality also. Okay. And what will happen is, always we will keep executing this functionality. And whenever we keep running this functionality, it is going to check whether this is working as expected or not. First, understand it, then we will take some notes about it. Okay. Put your attention here. What is going to be the process? So there is a developer. We will ask the developer, okay, hey, do the functionality. So this guy is doing the functionality. Then we will ask, along with your functionality, also do unit testing. Means write a test class, additional class. And here you need to write code which is going to verify this code, whether it is working as expected or not. So the developer will say, okay, let me do this additional coding also. Today we will understand how to do this additional coding. That is what is the topic for today. Functional we already have built. Now we will today focus on this part. So now what is going to happen? Developer is going to somehow implement this unit testing. And then it will execute this unit testing to make sure if this code is working as expected. And that's it, he leaves the system. Now what will happen is, we will keep running this code again and again for the end of, till the end of the project. So every sprint, whenever we are taking some code to production and all, we will continuously keep running all the past unit testing. So just imagine if it is 2025 and then December of this month will, December will come, and then 2026 will happen, and then 2027 will happen. The point is, the code which was written, test code, which was written in 2025, it will keep executing always in future. And whenever a developer, let's say new developers are coming, if they break this functionality, this code which was written in 2025 is going to identify that something is broken. That is unit testing. So how it takes an impact. So even let's say the people who developed this code, they left the company, still their test code will always keep running every single day till the end of the project cycle. Every sprint, you keep running this. And let's imagine if any developer makes changes into this system, which is breaking the code which was done in 2025, automatically everybody will know that, and then people are supposed to fix it. Okay, so that's how unit testing is powerful. Even without you, your code will keep making sure that existing system is working properly. Every time somebody modifies that and breaks it, this unit testing is going to tell to other people, hey, something is wrong, the code is not working as expected, and then we have to fix whatever is broken. Okay, so guys, what is the journey of unit testing? How unit testing takes effort? Okay, along with functional development, developer has to do this. This is not going to be done by testers. Okay, so along with functional development, developer needs to also code unit testing classes. Okay, aim of unit testing is to write test code which verifies if functional code is working as expected. Aim of the unit testing is this: to write some additional test code which verifies functional code is working as expected. Next, this unit testing code will keep always running throughout the life cycle of the project. Always, every sprint by sprint, it will keep running throughout the life cycle. Okay, next, if in future anyone breaks the old code, then unit test code will identify it immediately. That's the power of unit testing. Nobody needs to tell. Your code itself is verifying. Okay, even though let's say you have done all these activities, Jira ticket, documentation, and try to do your best. Even after that, if you're breaking anything in the old system, if previously, if you don't have unit testing, you will deploy these changes to customers and customers will face problem. Right now, that is not going to happen with unit testing. Let's say in future, if anyone breaks the code, unit testing will identify it immediately. Then as a developer, you have to fix the unit testing code. That is what it is. Okay. So there is one more need of unit testing. I'll give you another scenario also. Two needs we have understood. Let's understand there is one more third major need of unit testing. So people might get into this discussion of unit testing during interview time because it is very basic. So interviewer might be interested to know your views about unit testing. So there could be third possibility. Okay. Just imagine third scenario. First I will explain, then we will write a conclusion here. Let's take a third scenario. So this we can say process or how unit testing protects your code. This can be that title. Now let's take one more scenario. Sprint by sprint agile development is happening. Every 2 weeks, some features will be taken, features will be completed. So sprint 1, let's say you have developed 10 features, or generally people develop around, depends upon the team size, but one person on an average in 2 weeks, what can happen? One person can develop, okay, 2 to 3 features. And in that, 2 features can be still big features. One feature will be a bit smaller in size. This is the best that can be done within 2 weeks of time. Best. Okay. So 2 to 3 maximum features. Nobody can do more than that. If it is very small, like only changing a line, then you can do many. But generally, on an average, one person can do 2 to 3 features per sprint. Now, depending upon your team size, generally 3 to 4 developers will be there. Then there will be, let's say this is 3 to 4 backend developer. There could be, let's say 1 to 2 front-end developer, and there could be around 2 tester or QA. So by this, your team size is going to be 4, 5, 6, 7, 8, around 7 to 8 member team size is going to be there, which is a combination of these people. Then additionally, DevOps and other guys might be there. But general team sizes are this much, 7 to 8 members. And in that, they will have these kind of roles and doing the work. Different situations, people might do some changing around here. They might hire full stack and say, you itself have to act like front end and back end also. So we are not going to hire separate front end people. So sometimes companies will do that. In some of the projects, they might say, we are not going to hire testers. Developers itself are supposed to do testing also. Sometimes these variations will also be there. Okay. Anyways, the point I am trying to tell you is, let's say in sprint number 1, we finished 10 features. In sprint number 2, you're doing another 10 features. So guys, what is happening? 10 plus 10, 20. Just imagine over a period of, let's say 6 months, you finished many sprints. So now let's say your sprint number 40 is running, something like this. It is very much possible that as part of this sprint 40, you might have completed, okay, around, let's say 300 features. Sprint 40 is a big number. Every sprint you're doing 10 features, right? So you might be doing like 400 features here. So when the sprint 40 is done, as part of that, you completed past 400 features and you are doing plus 10 feature. Now, please understand the problem here. Every time you are building new features, you will be touching the old microservices. It's not like every feature you need to build new and new microservices. Microservice architectures and all that, service are defined maybe one time, K10 service. And then when you add new features, you keep changing in these 10 services only. And if a requirement comes of a new service, then you will do it. But it doesn't mean 400 features means many independent services will be there. No, maybe in the same 10, 20 services, you are adding new changes. What does this mean? Every sprint, you are making modifications to the existing microservice. And now comes the question, how can you give a guarantee that your past 400 features are always working and you have not broken them? Think about this question. Always you are modifying the existing services itself. Knowingly, unknowingly, problems can happen. Nobody is doing it intentionally. But when you touch the old system, and you have to touch it because new features are coming, you need to add it in the same microservices. So you will touch the classes, you will write new classes, you will write new methods. Knowingly or unknowingly, when you're developing these 10 features, how do you make sure these 400 features are not broken? Manually, it's not possible to take care of this. How can you keep testing all your past features? Just imagine if we ask Microsoft or Facebook, okay, hey, whatever you did in the past 10 years, every 2 weeks you need to test everything. They will be like, are you crazy? How is that possible? Humanly, not possible. So this is another scenario. Okay, if you have unit testing, every sprint, we will be able to verify all the past features which were developed. That's another powerful need of unit testing. Always your entire system will be tested whether it is working as expected or not. Okay, so that's the third need of unit testing. So we can say need number 1, next need number 2, and third is every sprint we add new changes. Okay, we should be sure all the past features are working as expected. It's not possible to manually verify. So unit testing is needed. Unit testing can verify that. How can unit testing verify? Okay, same concept, what we discussed here, approach. For all those 400 features, people will write these additional classes, and these classes will continue to run forever. And computer is running it, so it will just run all the 400 features. It might take some time. That is okay. You might just run it overnight. Let's say after office, for 2-3 hours, it is running all your features. And if there is any problem, it will capture all those problems and drop an email to you. So automated wise, we can run it. So it doesn't take much of your time also. Overnight it is running, over weekends it is running. It can be arranged. Now, if you really observe, we have seen that feature, right? Even yesterday when we were coding, when we do clean package, what happens? First compilation happens. After that, unit testing executes. We know this thing already. That is where we have done, I think few days ago itself, skip test option. Skip test. For some reason, when we were building for dev environment, we did the skip test. But if you don't do, the default behavior is what? Every time you are trying to do a package, it compiles the code and it runs the unit testing. What does this mean? It's all going to do this work only. It's all going to do this work only. All the features of this current microservice, okay, for them we have developed unit testing. Whenever you do a package, let's say you want to deploy it on AWS, you're doing a package. As soon as you do the package, all the past unit testing code will be executed. So if it fails, your jar is going to fail. And then as a developer, you need to first fix what you have broken. So what is happening? Unknowingly, you cannot break the system. Okay? If accidentally you are causing problem, during package time, your package itself statement is going to fail, your jar file will not be prepared, and automatically you have to see what the problem is and then fix that problem. Then only your packaging is going to work. And that is the thing. In the process itself, your unit testing is merged. Every single time when you do package, your unit testing verification will happen. If it is a breaking change, you have to first fix it as a developer. Okay? So guys, are we getting the base concept of need of unit testing? Simple hai, okay? So unit testing, you need to write additional code which will keep checking your code, and this code will keep running always. And whenever you have broken any existing code, this code will say, hey, there is a problem, somebody has broken it. Then you have to see what that problem and then fix that problem. Okay, fine. Chalo, now let's just, before we get into technical coding and all those things about unit testing, one more problem I want to discuss with you. So please put your attention here. Okay. There is a, okay. So first thing what we realize here, okay, along with your code, you need to do additional coding. And this additional coding and then testing is also going to take time. So practical problem now we have. Let's say for developing the feature, let's say for functional development, just imagine we did functional development for entire 2 months of time, whatever, from week 3 onwards, one by one, we are building the features. For that itself, daily 3 hours. And when you are implementing it, you might have realized it takes even 4 or 5 hours sometimes. So we did so much of functional development. So let's imagine for a feature, it takes 2 days of time. 2 days of time. Now, companies are saying, along with functional development, also do unit testing. And this is also going to take additional time. It's not going to be magic. So this is also going to take additional time. Very easily, 50% time is on an average. It takes 50% of the time. Means if your total development time is 2 days, easily it is going to take you 1 day to make unit testing code. This is almost an average or minimum side you can consider. Sometimes it can even take equal amount of time, maybe 2 days for completing the unit testing. And there have been cases, sometimes even more than that, maybe 3 days might be required additionally to do unit testing. It's not just something you can just finish it like that. It will need time, thinking, testing, and this is now additional work. So now what happens? Some of the clients or some project members, they might simply say, okay, hey, give me the feature quickly. And now you are saying, okay, I will complete it in 2 days, but I additionally need 2 more days for writing unit testing. Means total feature will take 4 days. All of a sudden, what will happen is, if let's say per sprint, you are developing 10 features, if you start implementing unit testing strongly, you can deliver only 5 features. On an average, if we talk about. So you will develop only 5 features. Now clients will be, come on, what you guys are doing? You are a 7-8 member team and you are delivering only 5 features. We are not okay with this. We want these functional releases because our customers need this feature. You might say all your explanation, but the client says deadline is important. We need to give the product there. You might say, but quality is also important. They will be like, but yeah, ensure the quality, but still give us the product quickly. I cannot give you double the time. These kind of negotiations will happen in your project. So even though clients might know this is the right thing to do, but they are coming from business side. They don't care what your development practice. They will just draw conclusion. The tech team is slow. They are not able to deliver. Let me take my business somewhere else and give it to some other technical company. So we need to be fast. We need to gain confidence of the client. So the business is happy with the team delivery. So you cannot simply say, no, 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 we will always do. Sometimes you might not even get the approval to write unit testing because of these situations. But then as a technical team, you have to then really convince your clients about need of this. Because what is going to happen if in your project unit testing is not there and clients are saying no? Once you start developing new features, you will realize you will start breaking the old features. And then once you go to the production, and features are broken, live customers are going to start complaining, and then the client will blame you only, saying, okay, come on, every time you develop a new feature, you are breaking the old system, so your quality of work is not good. So client will act like this, both the sides. First they will say, give us quick. Then when it is broken, they will blame it on again the technical team. Okay, come on, how did you guys do a bad job? So quality, so that means technical people are responsible for quality of your software and also speed of delivery. You need to strike the right balance. So as you gain more seniority, you have to really convince the clients and other people how important these things are, and we have to definitely implement it. It's not optional. Please understand, it is not optional. Some projects which understand this point, the importance of unit testing, they will never make it optional. Okay, some projects will make it mandatory. Without unit testing, your code will not be taken to production. So multiple scenarios are there in IT industry. Some projects might not prioritize unit testing because it takes double time. Some projects, unit testing mandatory. Without that, your code cannot go to production. So these are evolved companies, these are evolved projects who have seen the pain. If there is no unit testing, how bad the project is going to become, and after that they have applied it. And now guys, there is this one important thing you need to understand. After AI is there, after the time of AI is helping to generate unit testing. So it is not needing this much amount of time. You can give your entire functional class to AI and say, write me unit testing. Within 5 minutes, you will have all your unit testing also. What you need to understand, how to work with it, if it is correct, if it is not correct, you need that understanding. But using AI, you can develop it very quickly. And that is the reason now it is becoming mandatory for every project to have unit testing. So with AI, it's not going to take this much of time. Within 5 minutes, you can do it. And maybe half of the day will be required to test it, to understand all those things. But very quickly with AI, okay, you can finish unit testing within a few hours, which was earlier taking 2-3 days also. Now you can finish it in like 2-3 hours itself, but you need to do testing. So half of the day you can assume, maximum 1 day, but it will not even take 1 day because AI is going to write all that code to you. So that's how AI is changing the development behaviors. So using ChatGPT or any other kind of tools, you can just get your unit testing nicely. So today we will even see and try to generate some unit testing using AI. But in order to understand that, we need to have understanding about unit testing. We need to have first code-wise understanding of how to write unit testing. There are a lot of technical details and new things which we will learn in the journey. Once you understand those core things, then using AI, you can develop unit testing very soon. देखो guys, you have to always understand. If you don't understand what code AI is giving, it will be magic for you. And AI might give you very correct code also. But if you don't understand what that code is, when bugs come, you will never be able to fix it. You will again take this code, give it to AI and ask, hey, this bug is coming, please fix it. Very soon, you will not be able to control the project. And such people will definitely be laid off because as a developer, you cannot find things in your code. You cannot debug problems in your code. You cannot fix problems in your code. You're just relying on AI and you don't even understand what is happening. Such developers don't have a future. So AI is going to speed up, but you cannot blindly just rely on that. You need to understand what AI is giving. You need to be able to debug that. That is where coding skills are required. So coding skills are not required so that you develop everything from scratch and do very hard work. No, you have to use AI. It is 10 times faster. But why do you still need coding skills? So that you understand whatever AI is doing, is it right? Is it wrong? Is it applicable for your project? Not applicable for your project. If some code is not right, you need to be able to fix it also. So development skills required plus AI utilization skills required. So don't think कि नहीं shortcut ले लेंगे, no need to learn all these frameworks and everything. Directly we will use AI. Arey, how will you really understand if you don't know the basics? That is where today first we need to understand what is unit testing, what are the primary annotations, why we use it in that manner. There is a lot of conceptual learning in that. And then using AI, you can speed up your development, finish things quickly. Okay, fine. Now there is one problem with AI while you use it for unit testing. Just imagine, okay? So in your project, different situations will be there. Let's say there is a class, my service. This class is having, let's say, 200 lines of code, LOC, 200 lines of code. Let's say you are writing a new feature. For that, you have modified 3 lines and maybe added 2 more lines. Now, you need to understand that in all the projects, always unit testing is not going to be available. So it might be possible, your project situation is, in this past 200 lines, nobody has written unit testing. And now you have made these modifications and you know the seriousness of unit testing. So you started adding unit testing. But if you use AI, AI will generate unit testing for all the 200 lines also. So यहाँ पे you need to be really careful, because it is not your responsibility to develop all the past unit testing. Okay, the product owner or your managers, they might allocate some time. Okay, now we need to develop it for all this, and maybe take 3 days to develop for all the existing. But when you are developing your new feature and you changed only this much, so you are expected to write unit testing only for 5 lines. Now, if you are using AI, AI is going to take your entire functional class, develop it. So you need to use AI smartly so that you give your new changes and ask AI to give you only relevant unit testing. So for that also, thinking and maturity is required. You cannot always give your entire functional class to AI and write, because as you know, AI gives different answers different times. Maybe today it gave you different set of unit testing code. After 2 months, you tried to give all 200 lines, AI will give you different unit testing code. So we cannot blindly rely on that also. So just I'm trying to make you aware, even though AI is speeding up, but doing unit testing by giving your every functional class every single time to AI, you might get different results, which might kill your more time rather than solving your problem. So you need to be very careful what you are asking to AI, how much functional code you are giving, and you have to think about answer. And then there is a term called as cherry pick. Cherry pick the right code which you want. Cherry pick means one by one, the way people will pick cherry. So let's say in a cake, there is a cherry on the top, you will cherry pick, right? So AI is giving you so much of code. You need to cherry pick from that, whichever code you want to use it in your project. For that, again, core understanding of unit testing is required. So what are our conclusions? What are our conclusions? Okay, there will be some projects where it is not prioritized, but with AI, you can finish things faster. However, using AI, you need to be careful that only your newly written code, okay, that only for your newly written code, you are performing unit testing, not for everything from the past. AI can do that, but it is going to be a nightmare for you. Everything from the past, no. You have to do it only for yourself. So AI utilization should be done smartly, not blindly. Okay, fine. Chalo, now let's get into technical part of unit testing, of how to implement unit testing. Guys, are we clear with the base concepts, base understanding, whatever we discussed so far? That is the background. Okay, where it is required, why will some companies have it, some companies not have it, and then AI can be more powerful. This is base background, need, purpose, and solutions. A bit technical part we will see. Okay, maza aayega. Chalo, good guys. Thanks for confirming. Let's go. There are a few very basic rules about unit testing. We need to understand that. Okay. Chalo guys. I've put in a document. We will keep referring to that document also. By the end of today's session, I will share you this document. Some core bullet points about unit testing is mentioned here, even from technical aspect. So a lot of things along with some example code snippets. So by the end of today's session, you will understand all these technical things. Okay. But one thing you need to understand with regards to unit testing. Let's have a look here. Every possibility of code should be tested. Second, every class, now these are technical implementation details about unit testing. One by one, we will go through. Every class should be tested independently. Some mocking related concept needs to be applied. Code coverage needs to be used. You can test in your local machine itself. For many projects, without proper code coverage, unit testing, your code is not going to be taken into production. When you are doing unit testing, okay, this is some another concept that we will learn one by one. And okay, so accordingly, component scanning will not be there. So let's understand some technical aspects of unit testing now. Okay, first point, every possibility of code should be tested. What does this mean? Let's understand it. Okay. Now we are getting into technical aspects of unit testing. Okay, what is that? First, every possibility of code should be unit tested. Okay, what does this mean? Let's understand it here from this diagram. You created method 1 functionally. Okay, you created functionally method 1 and you created method 2. Now, if you want to write this code, which is going to verify your code. So let me do this thing. We will copy these two boxes, paste it here. Now, our aim of unit testing is we need to write code which is going to verify this code. So means you will be writing some code here. Okay. And in Java, when you write code, you will write some methods, right? Otherwise, how can your code run? So you will create a new class and you will write some method. Let's say test method 1. And in this method, you will be calling this method 1 somehow using the service object dot. You will call the method 1 and then you will check whether it is working as expected. This is what you will be doing. Okay. That is simply unit testing. So you will write your test class, you will write your test method. Somehow you will get object of this one. Somehow you will get object of this one. Let's say service object. And then you will call object.method 1. And then you will check whether this method is working as expected. Check if this method is working as expected. So this is what is unit testing. For this functional class, you will create a test class. In that, whichever class you want to test, you will create it as an object for you. Next, you will write a method. This we call it as a test method. And in this test method, you will call this method and you will check whether it is working as expected. How to do this? We will see that there are annotations for doing that. There are methods for doing that. Now, the first point we are saying, every possibility of the code should be unit tested. What does this mean? Now let's imagine if you have method 1. So yes, you need to write method 1 here to test how this works. Test method 1 is going to test your method 1. But just imagine inside method 1, you can have code which says if, right? If condition could be there. Next, else if is going to be there. We can do this kind of coding in functionality. So just imagine, here some lines of code is there, here some lines of code is there. Now, when you call this method for the first time, either it is going to meet this if condition or else if condition, or maybe there is a third condition which directly goes only else. That means in the same method, multiple conditions are possible. We can do coding like this. So if this condition is met, it goes here. Otherwise, it goes here. If nothing happens, it goes here. So same method is having now three possibilities. When we say unit testing means you need to test all of these possibilities. It does not mean if you have one functional method, then you need to write only one test method. No, that is not the concept of unit testing. Unit testing means for every method, each possibility you need to test. So what does this mean? You will create one test method for this functional method, but parallelly, you will create more test methods also. Okay, for example, this you will call test method 1, maybe scenario 1. And then you will create another method and call it test method 1 scenario 2. And then you will create another method, test method 1 scenario 3. Okay, this is how your coding is going to happen. Let's take a minute. I will shrink this size so it becomes more readable. Okay, this is how you do testing of every possibility. So for this functional method, it's not like you have to create only one test method. No, in the first test method, when you do, it is going to execute this method, that is fine, but it will be executing condition inside this if block. When you write second test method, you will again call method 1 itself, but here your logic will focus on testing inside this second if block. That means every possibility. So don't think like, oh, one functional method is there, so one unit testing method we need to write. No, that's not the case. For every functional method, every possibility, you need to cover in your unit testing. And when you're writing this third method, then you will be focusing that, okay, this third possibility is also completed. This is unit testing. So what exactly is unit test? For your functional class, you will create a test class. And inside that, you will write multiple test methods. So now some terminologies are coming up. This is called as what? Test class. This is called as what? Test class. These are called as what? Test methods. Test methods. These are called like test scenarios. In these test methods, we are testing scenarios. So people call it as test scenarios. Or people might also use the term called as test cases. Test cases, unit testing. So these are test cases or test scenarios. Okay, what you really want to test? We want to test this scenario where this if condition is becoming true, where this else if wala condition is becoming true. So these are some commonly used terms. Okay, so what will be our approach? We will create a class called as test class. Inside that, we will have test methods and we will cover multiple test scenarios or test cases in these test methods. And yes, you will get an object reference of this class and you will directly call those methods and then you will check whether it is working as expected or not. So that is what is this first statement. Every possibility of code should be unit tested. Okay, means for every method, each code block, nothing but if case, whatever, if, do, switch, each statement basically, you will pass it through scanner. Every possibility. That is what it is. For each method, each code blocks should be unit tested. That is what is the first important thing to understand. Okay, fine. Now let's get into a bit more tricky part. Put your entire attention there. This part was easy. Okay, now it gets a bit tricky to understand, and that is very interesting, also very conceptual thing, and that is the second point. Let's go to the second point. Okay, every class should be tested independently. Now this is a bit tricky to understand. Let's focus on this. Every class should be tested independently. What does this mean? Let's imagine when you are doing coding, right? When you are doing coding, you have written this payment service IMPL. Now, imagine you have another class. In our project, we created so many classes, right? We have another class, let's say some service helper class. And in this, there are some other methods. Guys, focus here. This is very tricky thing to understand and a bit complex also. So focus and attention is required. Now just imagine in this service, now you are creating an object of this service helper. Okay, let's call it as helper object. And this helper object you are calling here in this if block, let's say helper dot method. How your standard flow of execution will happen? Let's say whenever you call this, so let's say your this test scenario is running, it will call this method, right? Your test scenario is running. It will call first of all this method, then it will come to this place. When your code actually executes, how does it happen? It comes to this method, it goes to this place, then it realizes helper object is required, and then control goes to that method, then it executes that method, then it comes back, and then it resumes whatever rest of the logic, and then it responds back with whatever rest of the flow is there, right? Then it responds back with the rest of the flow. So this is how our normal core Java code execution happens always, right? When one class calls another. So let's say from some place, you call this method 1. So initially your control will come to this place, then it goes here, then it goes here, it runs, comes, executes, goes. That's regular flow. Unit testing changes this behavior. What unit testing is saying, every functional class, let's add a word here, functional, should be tested independently. Means when you are testing payment service IMPL, you don't test any other class. When you are testing payment service IMPL, you will focus only on payment service IMPL. You will not focus on service helper. Okay, what does that mean? If you are calling this helper.meth, you should not execute this one. Unit testing rules are different. Your regular execution will go there. Unit testing rule says, no, you are not supposed to call those external classes. Even though in your code you are calling it, but no, that code should not be tested. Okay, what does this mean? If you want to test service helper, you need to write another test class. This guy is also going to run independently. So in reality, when you are doing unit testing of this one, you only focus, listen to this part carefully. When you are doing unit testing of payment service IMPL, you only focus on the code which is written inside this class. If this class is calling other classes, you will not test them. It should not be called. Means if you want to test what happens to this meth1, then the expectation is you need to write another unit testing class for this called as service helper test. You need to write another unit testing class, and there you call this method, and then you test this method behavior here. But every functional class should be tested independently. This communication is not allowed. How to do it is very interesting. But first, get the concept here. Unit testing says every class should be tested independently. Means, okay, when you call corresponding functional class, then you will test the code only from that functional class. In case your functional class is calling any external class, then you are not supposed to do that unit testing in this test class. Okay? For the other functional class, you are expected to write another test class for unit testing. Okay? This is what it is. Let's try to give this some example name so it removes the confusion. When you call corresponding functional class, here we are giving the example, let's say this one. So when you call corresponding functional class means if you are calling, guys, please put attention here. When you call functional class, let's say then you will test the code only of that functional class. Means we are supposed to test the code only of this one. In case your functional class is calling any external class, what is that? Service helper. Relate it with diagram. If you're calling any external class, then you are not supposed to do unit testing of that in this test class. In this test class means in this service test IMPL. In this class, you're not supposed to verify other classes. Okay. For the other functional class means service helper. For the other functional class, service helper, you are expected to write another test class, nothing but service helper text. You are supposed to write another test class for unit testing. This is what is the meaning of every class needs to be tested independent. Okay. So very interesting, two concepts. Every possibility of the code should be tested. Means every conditions, every block of code has to be verified. Second possibility, when you are writing the unit testing for this functional class, you only verify the code which is written here. If you're calling somebody else, no, you're not supposed to verify that. Okay. Now, just imagine, how do we achieve this? It's a different way of coding. Let's say in this line number, your core Java has taught us that when you call helper.meth, always this method is going to be invoked. Now unit testing is saying, okay, this method should not be invoked. Means coding wise, it is going to be there, but it should not execute. How can we achieve this? I will again explain you the scenario, guys. Please focus. Let's say you have written the code. In your Java class, you have created helper, and that object you're calling a method. Now, in core Java terms, you know that when you call this method, you go there and you execute. Now, unit testing is saying, no, you should not do that. Means what? Means you will still have the code like this, helper.meth. But when you call helper.meth, your code should not go here, not execute. So how do you achieve this? That is where the concept of mocking comes in picture. Okay, you are supposed to mock. Mock means dummy. You are supposed to create a mock object for external dependent classes. These mock objects are going to be utilized by unit testing system. Okay, when you call methods on these mock objects, then actual method invocation will not happen. That is where mocking goes very closely with unit testing, because unit testing expects every class should be tested in isolation or independently. So here we can also use the term every class should be tested independently or in isolation. In isolation means separately, independently. So how do you achieve that? By the concept of mocking. What exactly is mocking? You are supposed to create mock object for every external dependent class. For our example, for service helper, you will create a mock object. And when you use this mock object for calling, okay, so it is not going to actually call it. So I think once you are seeing more of this from coding perspective, you will automatically understand that. So chalo, one by one, let's look at the code here and you will get the things clearly. Okay, chalo, let's go. Let's go. So basically, these two are the important things to understand. Remaining things we have already introduced. Mock any outside dependent classes. Later, we will come to this code coverage. You're testing it in local machine itself. Okay, for projects without proper unit testing, code coverage, your code will not be taken further. We already discussed that. Okay, this last concept we will understand still. There is one more interesting concept. When you are doing unit testing, Spring Boot container is not activated. We will understand that third point also, but that we will understand when we are actually coding it. But there is a third point. When doing unit testing, Spring container is not activated. Okay, there is another concept called as integration testing. Integration testing. During integration testing, Spring container is activated. But we are not going to do integration testing as part of our stuff. During interview also, you say we did unit testing, because unit testing tests everything very precisely, every method, every possibility in isolation. So this is very much mandatory everywhere. Integration testing sometimes will be required, sometimes not required. But anyways, for unit testing, Spring container is not activated. So that's how we are going to test it in isolation. So we will understand this concept later when we are practically coding it. Okay. So guys, let's pick up one of the functional class. Our most important functional class is payment service IMPL, right? Because that is the main class where we have all the core business logic. So wherever important business logic is there, we need to unit test that. So we will take example of, let's say, processing service core business logic. Just see, this much is the business logic inside this. Create transaction is there. Some unique reference method is also called. Next, initiate is there. Initiate is having business logic. We coded all this together. First, initiated status will be updated. Then you make a third-party API call. Then if exceptions happens, this block has to be tested. So what do you realize? Here you need to test all possibilities. You have to test a possibility where exception is thrown. You need to test a possibility where exception is not thrown. And then how it behaves in this case, how it behaves in that case. Everything needs to be tested. So I think this is a good main functional class of payment service IMPL. So we will do the testing of this. Okay. So what are you supposed to do? Let's look on the left-hand side. Your functional code is going to remain in SRC main Java. Your testing code is going to go in SRC test Java. That is the first thing you need to understand from coding perspective. Functional code is going to be in SRC main Java and test code goes in SRC test Java. Okay, that is first point. Second point, whatever is the class name and the package name of functional class. Okay, so let's say your functional class name is like this. This dot this. This is your functional class. For this, if you want to create a test class, you need to use exactly the same, and then end it with a test. So this becomes your functional class. You keep the same packaging, just so these are again good coding practices. You can write it other way around, it will still work, but it will add more confusion. So generally, whatever is your functional class package structure, you keep the same package structure in your SRC test main also, and whatever is the class name, keep it the same. Just important thing, put it under test. Okay, add a test in the end. So this becomes your test class. So let's create it. So I will be copying this class name, and let's create a new test class under SRC main, SRC test Java. Right click new class. I'm pasting it here. So same package structure, but class name is like this. Finish. Okay, super. Class is created. Okay, so class is created. Where is our functional class? Let me open our functional class. We will close this, or we will move this next to this place. So this becomes our functional class. This becomes our test class. So next to each other, so easy to identify and compare. Okay. Now, one by one technical complexity, let's understand. Now, in order to work with unit testing, there are some annotations which we have to use, and there are some libraries. So for implementing unit testing, there are some tools or some libraries we have to use. Okay, sometimes people also call it as unit testing frameworks. Some people might use this term. Nothing but in order to make all this thing possible of unit testing, test your code, there are some other set of classes and annotations which we are supposed to use. People call them as just libraries or unit testing framework. The popular unit testing framework in the market is JUnit. Also, some of the projects are using, for Java related guys, TestNG. Okay, please note this thing, unit testing concept applies in all programming languages. It's not a Java related concept. It applies everywhere. Front-end guys will also do unit testing, and every backend programming will have unit testing some or the other manner, right? Whether it's Python, PHP, Node, Golang, Java, whatever, everybody. So it's a concept across the industry. So in Java world, for unit testing, there are some libraries, some frameworks which we are supposed to use. The commonly ones are JUnit or TestNG. So we are going to utilize JUnit in our application. So if there are straightforward starters available for that, and we will get capability of JUnit. Okay, if you really look it in our code, right from the beginning, pom.xml dependency. Okay, pom.xml dependency. We have some dependency added saying Spring Boot starter test. Okay, this Spring Boot starter test automatically will give you JUnit related capability. So internally, they will look for all the JUnit dependencies and make it available for us. So we don't have to add it explicitly. Spring Boot starter test is going to add the required dependency for us. Okay, this will adds JUnit dependencies for us. Okay, now second, so these are nothing but called as unit testing frameworks. Some set of classes, libraries, annotations, methods, which is coming along with these, we can use for our work. This one provides JUnit dependencies by default. Okay, fine. Similarly, for mocking also, we need some libraries or some frameworks. The commonly used and the popular frameworks is Mockito, not mosquito, Mockito framework, or there are other libraries called as Power Mock. In different projects, people might use differently. For example, this combination is very common. JUnit goes with Mockito and TestNG goes with PowerMock. So people use it as a combination. Okay. But anyways, these are some names of the libraries which are used for unit testing. So we are going to work with JUnit plus Mockito combination. JUnit plus Mockito combination. Now, interesting part about the same package is, in the same package, they have also got the mocking library also for us. That is what the power of starters. Spring Boot feature starter. It is going to give you all the, like, basically ease of dependency management. Why they created these starters? Okay, whatever the people might need, they are bundling it and giving it. So you don't have to explicitly ask for it. So if you ask, just put a web starter, you get so many things. Tomcat is coming by default, and then web capability, JSON capability, so much things you get it by default. Likewise, just by adding this, you're getting unit testing capability, you're getting mocking capability. Without starters, you have to manually arrange all those dependencies. So starter is a good feature provided by Spring Boot to make all the relevant dependencies available to the developers. So same thing, just by adding this, you will also be getting Mockito dependency. So we don't have to add anything special also. Okay, fine. Fine, chalo. Now we need to write unit testing. Okay, so we go back to our code. Our code is payment service IMPL test. Where are we going to do our unit testing? So this becomes a test class. Now we need to write a test method. Now we need to write a test method. Let's name a method. Without a method, we cannot do coding in Java, right? Execution needs some method. So let's say, oh, this guy is already seeing, okay, what, that's what AI looks at the relevant classes and it is suggesting me like, okay, let's name it like test create transaction. Because in the functional class, there is a test create transaction. Okay, let's put it here. So first we will start with testing our create transaction method. Okay. Whatever logic is here, we need to test this. Dekho guys, proceed with unit testing with logic. Don't try to memorize it. What do we mean by that? Just observe and you will get the concept. Many juniors, basically, they try to remember a lot of things around unit testing. It's all about look at your functionality and write unit testing accordingly. Because every functionality is going to be different. So you have to do different unit testing for every method. So observe and learn here. Because every functionality you will write different. That means every test method that you would do is going to be different. So you have to really think when you do unit testing. Let's do it one by one. Okay, first of all, you want that JUnit should execute this method whenever we want to do unit testing. Okay, how do you do that? If you want to run this method as a unit test method, okay, one thing. See, right now I'm doing a right click, run as. So IDE is realizing how to run this. There is no main method. Otherwise, it will ask you, okay, run as main method. Okay, I think we can try experimenting here. This is a main method class. If you right click here, click on run as, just observe. IDEs are very intelligent. IDE realized, okay, because main method is available here, so we can run it as a straightforward Java application. Second, because at the rate Spring Boot application annotation is available, it realized we can run it via this option also, or Java application in container. Internally, it will launch a container, in that execute it. Nothing but IDEs are smart enough. Depending upon which class you want to execute, it is scanning and seeing, okay, so this class will have multiple options. Currently, we have done this test. Here, right now, IDE is saying, I don't know how to run this, because it's a simple thing. We want this to be executed like a JUnit test. For that, there is an annotation which we have to use, and the annotation is @test annotation. So whenever you give @test annotation, it's a JUnit annotation. Whenever you give @test annotation to a method, Control-Shift-O, just observe, it's a JUnit annotation. As soon as you give this, then this becomes a test method. Otherwise, it was a regular method. The way we do @post mapping, it gets a behavior, right? Like that, as soon as you put @test, the framework starts understanding, oh, this is where this is a test method now. Means I have to do certain different activity. Let me save the change and let us right click now and see run as. Now ID realizes, oh, this is a JUnit test. So fine, without the annotation, it is a plain method. So you need to write it like this. And you just execute it like JUnit test. So how are you going to execute it? Okay, how to execute? There are multiple ways. I'm showing you one of the way. One by one, we will see how to execute your test class. Approach is simple. Create a test method, okay, and annotate with this. Then on that class, right click, run as. Automatically JUnit test option is available. As a JUnit test, you can execute. Okay, let's do that. So save everything, right click, run as JUnit test. Okay, observe the way debug, another perspective came, right? Debug perspective. Whenever we run a debug, we get a different perspective here. Regular project explorer is available. Like that, when you are running JUnit, they have created a different perspective for this. Show view JUnit. So, okay, using the term like view here. So JUnit kind of view they have created here. So fine. So there is a left-hand side panel. Okay, for showing results of JUnit, a left side panel called as JUnit view is available in this IDE. Different IDEs might have different way of representing it. Now just observe there. It is clearly saying we are using JUnit 5. Okay, so versions will be there. So we are using JUnit 5 version. Okay, next, this is our class and this method is taken for execution. And it is somehow showing okay, total to execute this much of second time is required, 0.037. In that, this method fully executed. So that means using this view, we can get some output out of this. Next thing you need to understand, your logging is possible. So you can simply put @slf4j. It is going to give you a log object and you can do log object here. Save it. Once you have executed it, your last executed commands are all saved here. Last executed commands. So you can just click on this button and it will re-execute the same again. So observe, now when the method is executed, it is even printing the log statement. So you did test method execution. So fine, accordingly test method execution is printed. So simple, we have already written a test class. Key things you have to understand is only this much. Test class, test method, annotate like this. How to run, this is what? Simple thing. Okay, simple thing. SLF4J logger is there, it is printed. Okay, now next. What we are supposed to do in this test class? Think about it logically. What are we supposed to do? We are supposed to test this class. Okay, what does it mean? We need to call method of this class. How do you call a method? We need object of this class, and then we can call method. Where can you do that? In your test method, we need to call basics of programming. In this test method, so our next expectation is we need an object of this class. Private this, let's say this object. Somehow this object should come to us, and then on this object, we are going to call this method create transaction with some request parameter. Okay, let's say create transaction request. Create transaction request. Let's create one object. We need to call this. Right now, I'll just put a new operator like this. This is what we are supposed to do. So our basic aim is we need to call the functional method. So here we call the call functional method for testing. This is where you call the functional method for testing. Here you are arranging the data. Arrange data for calling functional method. So basically, you have multiple actions here. This part, we call it as arrange part. This part, technically, we call it as act part. Nothing but you're taking action. And I think the third part is called as verify part. So that means there is a way to write this method. The business logic in this method, you will break it down into 3 areas. Okay, let's just check the technical naming of that. Arrange, act, and assert. So the first part is arrange part, where you arrange the data for calling. So this is the arrange part. This is act part, and this verify third part, we call it as assert part. Here we are going to do verification. So what do we learn from this piece? For writing test methods, there is a structure. You have to write it in 3 parts. 3 parts. When you do code, always remember this. Part number 1 is arrange. Part number 2 is act. Part number 3 is assert. One by one, we will understand these things. Main is act is where you call functional method. Arrange is, okay, arrange the data. Arrange data needed to call functional method. And assert is verify. Verify if everything happened as expected. Okay, fine. So this is the next topic. Your test methods needs this kind of structure. When you convert it into code, basically it means this only. We want to test this class, means we need to call the methods of this class with certain data, and then we need to get some results. Okay, fine. So I think this is clear. Now, let's try to understand it even more. Your core Java knowledge tells you we have not created this object. New operator is not there. Okay. We have not created this object. Second thing, Spring container is also not there. When you run unit testing, Spring container does not get activated. For example, let's try to experiment here. Okay, one by one, we will try to experiment. I will try to put a breakpoint here. The way we can do run as, we can do debug as also. Let's try to check it one by one. Right click, debug as. Okay, instead of run as, now I am saying debug as JUnit. Okay, so it came to this method, it is executing it, it came to line number 21. We do a mouse over, basically null. Okay, basically null. So the value is not there. Okay, fine. Let's release. Next, let's try to make this as a component. I'm just experimenting. Let's try to make this as a component. Component makes it a Spring Bean. And let's try to do this at the rate auto wired. Just trying to use Spring related knowledge since we have it. Let's see what happens. Okay, let's see what happens. So this could be one style where this object is going to come to you from the Spring container, and then you can use it further, right? Let's try to run this method again. Right click, debug as JUnit test. Okay, you are into the breakpoint. Still the object is null. We know that if the current object is a Spring Bean, so Spring is going to create an object of this test, and whenever we do auto wire, Spring is going to get this kind of an object and give it to us. But still it is not there. What does this mean? This is a practical proof. Spring container is not active when you are running your unit testing. Spring container is not active here. Accordingly, this component is not created, this injection has not happened. So Spring is not functional in this case. Please understand that. So that's the next point. We left this point some time ago. Okay. So let's write it down. When running unit test cases at the Spring container is not activated. That means all that dependency injection, dependency lookup, component, all that knowledge is not applicable right now. So how did we test this? How did we verify this? We use these two things, at the rate component and at the rate auto wired. And yes, it is not providing us the object. We verified it right now. Still, this reference is coming as null only. And if you try to call on null, basically exception will come, right? So if you try to run this, it is supposed to throw an exception. Null pointer exception has happened because this is null. The reason is saying, right? Fine. So that means regular way of Spring object creation is not applicable for our unit testing. So we are not supposed to do this way of object creation. That's a big conclusion. Okay. Regular Spring way of object creation is not applicable during unit testing. Dependency lookup or injection will not work because Spring container itself is not activated. As Spring container is not activated. Okay, then how exactly we can get it? Okay, one way could be, as a developer, you will start thinking, oh, then I have to create a new operator, right? You can do a new operator, and then going back to our old core Java style of coding, I will do a new operator and then I will do that. But guys, there are some problems here. Okay, what? If you are creating a new method, let's say here, new of payment service IMPL, Control Shift O. Okay, compilation wise it is failing. Why is it failing? Because in payment service IMPL, there is a constructor. We have used this. Because of this, we got a constructor, Control O. It has parameterized constructor. So that means if you want to create an object, you need to use the parameterized constructor, core Java knowledge itself, right? We need to create a parameterized constructor, and it is expecting you to provide 1, 2, 3, 4, 5 objects. What does this mean? If you want to create this IMPL object, you need to create 5 other objects also, and then you need to call this parameterized constructor. And you're creating this object again for these other objects, you will create them using a new operator. because of your core Java style of coding, you are going to violate mocking behavior. Let's say while creating this object, you need an object of service helper. If you create this object with a new operator, it will behave like your core Java flow, where it will go automatically, call the method, but unit testing says it should be tested in isolation. So we cannot use new operator for creating these objects. We need special behavior. We need mock behaviors. So this unit testing and mocking has given a different way of object creation. That's what you need to understand. Okay, very interesting. If you are using new operators, when you call this helper.meth, it will actually go there because your object creation style is different. We need a mock object because we don't want to test this. So you should not use a new operator. You should use a mock way of object creation. Okay, so let's try to draw a conclusion. Then we will go into code. One by one, we are learning things. Okay, so since Spring is not active, how do we get object of functional class? That is our main question right now. Okay, one thing which strikes our mind is use new operator. Okay, but in this case, we need to create objects or object of payment service IMPL. However, before that, we need to create object of other dependent classes, and for that also you will use, so because you know only new operator, you will use new operator itself. Use new operator. If you do this, the problem here is, if you use new operator, when functional class calls your helper class, then code will execute helper code also, and this is violating the unit testing principle. This is in violation of unit testing principle, which says every class should be tested in isolation, which says every class should be tested in isolation. So how exactly we do? Okay, we have another set of annotations here. We have some annotation called as @mock annotation. Next, we need to work with another behavior called as @inject mock annotation. And we need to use one more thing called as @extends. And here we have to say Mockito extension. Using these three annotations, it will create the required objects for us, the required mocks for us. It is how, using unit testing and mocking style, we manage our objects. So far we work with one annotation @test, but now we need objects because we want to call it. Now we need some mock objects, we need proper functional objects. In order to do that, we have to use this behavior. Okay, how exactly? So where do we use inject mock? Inject mock is supposed to be used on your functional class. Wherever you are defining your functional class, that class you need to use along with inject mock. And this regular mock is all for your other dependent classes. One by one, we will understand this. And extend is with, it is on class level. Ek ek karke let's understand. You will go here. Okay. Just observe, we will use the three annotations technically, then you will understand. At class level, on this test class, at class level, so first we should not use new operator. That's not the right way. So without new operator in our current code, basically this value is null and it is failing. So we can debug it. You come here, value is null, it is going to fail. Okay, fine. So far we are on the same page. The value is not there. We know core Java, if it is null, null pointer exception is expected. Everything is good so far. Now we need this object. What are we saying? There are more annotations. We need unit testing and mocking way of objects so that we can achieve our unit testing effectively. How do you do? At class level, you apply this annotation at the rate extends with, okay, Mockito extension, this one, Control Shift O. Okay, let's wait. Extends with Mockito extension, Control Shift O. Yeah, this one. So we are saying, okay, here we need some mocking capability. If you extend your class with this annotation, then you get some mocking capability, means dummy objects will be created, and this framework is going to manage objects for you by using this kind of an annotation. Next, we said, whichever is your functional class, on that class you use this inject mock annotation. So you just go here and then you use @inject mocks, Control Shift O. Yes, you get this annotation. That's it. Now you are asking the framework, the mocking framework, the unit testing framework, okay, hey, I need object references so that I can do my work. Okay, let's try to debug it once more. Okay, we come here and observe now. The object reference is not null. It has created some object. So earlier null pointer exception was coming because this object was null. But after applying this plus this, we are getting this annotation. Okay, now you can do some experiments. If you don't extend this, okay, let's go here. If you don't extend this, you stop this class, saved, trying to test it again. Let's try to go here. Null. Mocking capability does not come. So you need to use a combination. So this will tell the mocking framework, okay, for object creation, we need their help. So how do you say that? Using extends with Mockito extension, it gives a special behavior to this class. And we need this functional class because we want to call it. So there you have to use @inject mock. So this is how we have to use these two pieces. So what will happen because of this? Let's close this, debug it. Now we are able to see object reference is available. That means if we do step into, we should be able to go there, right? So do a step into. Nice. We are able to call this method successfully. But in order to call that method successfully, we had to make these two arrangements, right? Guys, are we clear with this? Team, are we clear with this? Why we cannot use new operator? Because if you manage it, when one class is calling another class, mocking behavior will be completely gone. So we need a new style of object creations. Framework is providing that. For that, new annotations we have to learn. Extends with and inject mock. Combination of this has given us an object. We are able to call the methods. Wonderful. Okay, let's continue further. Super. Okay, now let's start understanding other things. This mocking is very interesting, guys. Okay, we are able to call this object. This object has internally these many number of reference variables, other dependent objects. Currently, we have not done anything for all of these things. And observe, model mapper is supposed to call on line number 47. If you do a mouse over on model mapper is null. So inject mock has somehow given us reference only of payment service IMPL. It has not initialized any of these things. So it is null. Now what is going to happen? If you run your unit testing, this is going to break. Yes or no? Because null pointer exception is going to come again. So automatically the value is null here. If you are releasing the thread, we are again getting exception. Means our unit test case is not done properly. Our unit test case is failing here. And now the reason for that is, yes, there is a null pointer exception. Model mapper is null. They are clearly saying, and the problem is happening at line number this one. So we have a situation. So just imagine these helper classes are there. HTTP service engine is there. These are external classes. Like that, model mapper is also an external class. All of them are null for us. So if everything is null, basically system will not go further. So now our expectation is all the external classes should be mocked. Just imagine, currently our payment service IMPL is expecting some object of this one, which is null currently. It is expecting some object of model mapper. It is expecting some object of these remaining three also. It wants all those objects, but the mock behavior inject mock has not created any of those objects. All these objects do not exist right now. How can we get that confirmation? Okay, we can check it here. You again run the breakpoint. Run the breakpoint. Mouse over on this object which is created. Observe, everything is null. For this object, only this object reference is available. Inside that HTTP engine model, everything is null. So when you use this kind of inject mock, it has given only object of this one, but it has not initialized any of these other things. And that is the reason your unit testing is failing. Now our expectation is we have to initialize these dependent objects. Otherwise, we cannot even continue further. Okay. Again, two ways are there. Do you want to create a new operator? No, we don't want new. We want a mock behavior here. So that means our current class is needing all these things. But we don't want to use the regular objects here. We need mock behaviors. What is a mock behavior? It means dummy object. Okay, even if I call method of this, it should not go inside that. But object should be available. How do you achieve that? For that, this third annotation is there, @mock annotation. For all your dependent class, we need to use @mock annotation. What is going to happen? You will get dummy object references. What is dummy? Means even if you call methods on mock objects, still methods will not be invoked. Special behavior, a different style of programming basically. When you do this @mock, you're calling method, it will not be executed. That is wonderful. Okay, let's see how we can do that. Okay, very simple. What are we going to do in code? All these 4 objects that we have, we will take it, we will go to our test class, we will define them here. Okay, don't use the final term. Okay, we will not use the final term because here we are operating differently. And then for each of this, we are saying @mock annotation. So wherever mock is coming, now mocked object, dummy object is going to be provided by the mocking framework. Just see. Everywhere now we want a dummy object. If you don't do this, basically null is happening. Now the framework is very intelligent. I think now you can understand the meaning of this inject mocks. Inject mock means, okay, let's try to first execute it, then we will understand the meaning of inject mock. Okay, let's save everything, debug it once more. Okay, let's do a mouse over here. Observe. Now, earlier, all these objects were null. Now, all of a sudden, objects are available. What happened? Now, mocking framework is in effect. Mocking framework has created dummy objects for all of these things. And wherever you use inject mock annotation, it takes these dummy objects and is injecting it in this one. And that is the reason the naming is going like inject mocks. Okay, on this class, you inject other mock objects. And this is the main functional class which we use for our testing. So what is our learning here? The functional class which you want to test, you need to use @inject mock annotation, and whichever other dependent classes are there, you have to use @mock annotation. And to get this mocking behavior and injections happening, we need to extend with Mockito extension. So a combination of this, we get the required objects for working. Okay, wonderful. We have already taken the note of this, so we can go further. @mock your other dependent classes. Okay, you will get dummy object reference, blah blah blah. Okay, this is done. Now let's continue further. Let's continue further. So here we are. This object is not going to throw null pointer. So we have an object. We can go inside that. Okay. Next, whatever you passed, create transaction. You did not create any value there. So everything is null here. Should you create all the values? Should you not? It depends upon what your business logic is. So right now, I am not populating any value, because depending upon my business logic, I will see whether I need to populate or not. Right now, only a dummy value object we have created. Just observe. Empty object we created, we have passed. Should you populate all this, call the setter for everything or not? It depends upon what you are unit testing. So currently, I don't see a need. I'm not creating anything. Okay, fine. Now let's continue further. Let's continue further. Now, this is a very interesting observation that you will have. Earlier, model mapper was null. Now, model mapper is not null. It's a dummy object. So null pointer exception is not going to come here. Okay. So let's go further. You go here. You go here. You go here. Null pointer did not come. In the previous case, when this object was null, null pointer was coming. Okay. Now, there is something for you to think. The model mapper map method does what? It takes the incoming object and converts it into a transaction DTO and returns a DTO reference back. That's the regular behavior of model mapper. Now, we have ran the code. There is no exception. But if you do a mouse over on transaction DTO, the value is null. What does that mean? This model mapper is not a regular object of model mapper. It is mock. It is dummy. So it is not executing the business logic. It is only giving you the return type, which is dummy default values, which is by default null. So when you work with mocks, the behavior of your system completely changes. It does not execute functionality. That is what is going to happen if you call even helper related methods or anybody else. Because of mock method, it will not execute that logic. It will only give a return type, which is default, which will be null in most cases. If it is an integer, it is going to be a 0 value. If it is a Boolean, it will give accordingly whatever may be false or default Boolean value. And that's how the behavior will be. So this is interesting. This is different than core Java programming. So object is called. Expectation is that it should work. But because it is a mock object, it behaves differently. And what is that? It does not call this method. It does not go inside this map method. It does not run any logic. It only gives you dummy return value, which basically is null here. It did not add any intelligence. Dummy hai, aage nikalte. Guys, this is very important to understand. This is very important piece. When you use mock objects and call methods, the methods don't execute. They don't execute. Only dummy return values are returned. So mock behaves differently. Very important thing to understand here. Okay. So when we have already written here, you will get dummy object reference, even if you call methods on mock object. Okay. Still methods will not be invoked. Direct dummy response will be provided. Okay, fine. So far we are understanding the basics of how these unit testing mocking works. Let's continue further and try to complete our full flow. Now what is going to happen? You are setting up a reference. While doing unit testing, you need to look at functional code, and accordingly you need to write your unit testing. because every time functionality will be different. So your unit testing is going to change always. Observe, just observe. You will learn a lot by just observations here. So we are here till this point, code is running fine. We need to make sure this entire code runs fine and returns a value. That is our target. Anywhere if it is failing, we need to do some changes for that. So as a developer, you have to make sure every line runs and this final value is returned back. Okay, let's try to do that. So we did a create. Okay, we called generate unique reference. So transaction status is created. Okay, very good. Next, transaction reference generate method is called and it is generating a UUID. Okay, very good. Next, line number 54 is doing what? Observe. It will fail at line number 54. Why it will fail? Array, this line number 47 did not give any object in return. Now your remaining code is expecting that you should get a valid object, and on that object you want to set the status, you want to set the reference. If no object is coming, these two lines are going to fail. That is where at line number 54 our unit testing is now going to break. Unit testing null pointer at line number 54. So now what is happening? When you call this method on dummy object, mock object, it did not give a return value. Because of that, it is failing at line number 54. So our next target is we need to override the behavior of mock object. We need to override it because by default, okay, it is giving null. Okay, when you call method on mock object, it gave null, which is breaking our further functionality. It's breaking our further functionality. Now what we need to do is, instead of null, we want the mock object should return us some transaction DTO object so that our remaining code works. Otherwise, code is going to fail. How do you do that? Okay, for that also new technical things we have to learn. You have to override. We need to override the default. Everything is logical. Try to understand it logically. We have to override it. Otherwise, you cannot run your next line. So we need to override the behavior of mock method. How can we do that? Okay, let's see. Very interesting. New things you will learn, but very interesting. What we will do is, we will copy this model mapper. Let's go here. Okay. In the arrange part, you arrange all the data required for successful execution of this method. So in the arrange part, just observe what I did. I copied that. And now I'm doing a when. Just observe. Okay. I'm using GitHub Copilot. So I need intelligence of AI here to give me the syntax and complete the stuff for me. Okay. Let's understand it one at a time. Control Shift O. Now new syntax we have to learn here. What is that? When then syntax. Using this when then statement, okay, when then return. Using this when then statement, we can override the behavior of mock. Okay, what are we saying? We are saying whenever we are running this method, okay, when model mapper dot map method is called, using this create transaction request and transaction DTO class is passed there. So that means whenever this is done, previously it was returning null. We are now saying then return a new transaction DTO object. That is a when then. You are able to override the configuration. The syntax is very simple. When, then. You can directly understand. Okay, when this happens, when this happens, then do this. Then return this. When then statement. Okay. Now, what is this when then statement? It's again your core Java only. Don't assume it is some other logic here. These are basically methods. When is one method, which is simply object chained, right? When you call a method, it is going to return an object reference. On that object reference, you're calling another method called as then return, and you're passing something. So it is your object-oriented programming style only. It's not something else. How come you're able to directly use when method? Who has defined this when method? Observe here. In Mockito, this is defined. I'm doing a F3 here. In Mockito class, when is a static method defined? In core Java, you would have learned the concept of static imports. That static methods can be directly imported in this manner, and we are using that static methods here. So it's nothing different. It's object-oriented programming only. In core Java style, we already have it. Just we are using it now. When, then style. Okay, so when is a static method in Mockito. When you do that, okay, the return type of when method, just observe. The return type of when method is ongoing stubbing. Okay, and if you go here, F3, ongoing stubbing. Now let's observe here. This then return, I'm getting inside then return. Okay, it is available inside ongoing stubbing. So now we can understand that whatever is the return type of this when, it is nothing but nested call, nothing more than that. Method chaining. So what is this syntax? Let's try to understand. When, then, when this happens, then return that. So this is this is that. Okay, and how are we doing this? It's again core Java basic principles. We are using, okay, static import of when statement. Okay, it returns object of ongoing stubbing. It returns object of ongoing stubbing. Okay, and on the object of ongoing stubbing, we call then return method. So basically like that. But what it achieves, it overrides the behavior of mock method. So when then is that syntax. Currently we are saying, okay, when in our functional class, let's observe here, save. We are now telling the system, okay, whenever in our functional class, we call model mapper dot this object reference and try to do it like this. So whenever we call like this statement, in return, earlier it was giving null. Now we are saying, give me an object of transaction DTO. We can simply create it like this. We can simply create a transaction DTO and then create a new object for ease of coding. Here we can pass it new transaction DTO, something like this. When then statement. Okay, fine. So that is what, guys, even AI might generate all this code for us, but you need to understand why mocks are supposed to be used. What is inject mock? What is test? Why exactly these when thens are required? Why are we really arranging this kind of data? If we don't arrange, then what is going to happen? That conceptual understanding every developer should have. Then use AI to get the work done. Okay, fine. Chalo, let's do the testing once more. Okay, we call this. Let's debug it once more. Here we are. Okay, next, create transaction. Let's get inside that. We just need to make sure the code executes starting to end, line by line, and that is what we are testing every unit. You will get to that part, how does it verify that code is all good? We will get to that part. Assertions is where that verification is going to happen. Assertion is the third phase. Arrange, act, and assert. In assertions, we verify if everything is fine. Arrange means just arrange the data so that we can run this act method. Assert is where verification happens. So unit testing ka verification part is third phase. We will come to that stage. We are right now just trying to work with these areas. That is a prerequisite. Once these two things happen properly, then we get into more assertions, verification, whether method is working as expected or not. Okay, fine. Okay, let's come back here. So earlier model mapper was null. So we provided model mapper mock object. Okay. So model mapper mock object is there. Next, on model mapper, when we call the map object, observe, earlier, when we call this map object, here null was coming. Now null is not coming. Transaction DTO is coming. Which is this transaction DTO object? You have defined it here. Internally, the framework is intelligent. It is checking that, okay, in the code, somebody has called this. And when somebody has called this, I am supposed to return this. We have overridden the mock behavior. And what is this? This is nothing but this object itself. So now, because this object is going, now our code will not fail at line number 54. Null pointer will not happen because object reference is available. Let's continue further. Okay, so we go here, we pass here, we get the reference, here we go. Perfect. That's all. Line by line, look at functionality and then decide what should be your arranging the data part. For your today's coding, pick any other functional class of the project. So maybe you can start with this current one, but take any class and look at the functionality which you did, accordingly write the unit testing for that. Because every method is different. So every time this arranging the data part will be different. You need to know the basics how to do it. Then you can apply it for any business logic. Super. Let's continue further. Here we go. Reference is done. Here we are. Okay, transaction DTO. Just observe in the transaction DTO, status is saved as created and transaction reference value should also be there. So transaction reference value is also there. So fine, these two things are working fine. Next, what do? We call for some response. This is again dummy. So it will give null basically. External things we are not testing. So this is going to give us null. Response is going to be null. Okay, fine, expected because it is mock behavior. Our aim is the method should execute till the end and return a value back. That is what our aim is. So now we go further. What are we doing? We are creating a transaction response object. Okay, fine. Transaction response object. But in the transaction response object, we are using this response object. Observe. Response.get transaction reference and response.get transaction status. Now this response object is null for us. So again, it's a problem, right? Response object is null for us. Means here again, 63 will fail with a null pointer exception. So this is how you have to keep checking. Observe, it failed with a null pointer exception. Line number 63. Now as a developer, we need to start thinking, okay, how to do that? What is the solution? We have to override the mock behavior. Otherwise, code is not going to go forward. So our immediate next aim will be, we need to create this, we need to override this method. Whenever this happens, we need to get this reference back. Okay, whenever this happens, we need to get this reference back. So let's try to do that part. How exactly you do it? So we copy this, we go here, we again put it here. Next, we ask, okay, very good. When this happens, then return, we are going to get a response back. And this response, we will be creating new, this response we have to create it by ourselves, new transaction DTO ka response. Okay. So we are creating a new response. Now in the dummy method, now look at the code again. So if we just write that, this response object is going to be created. This transaction DTO response object is going to be created. Now again, it's a question. Do you want to create a new response object, or do you want to use the previous object? Now this is where developer decisions have to be done. Like when you are basically calling this status, the same previous DTO object itself you are updating also. So I am not going to create a new response object. We will return the previously created DTO itself. Okay, just observe. In the functional code, when we call this method, we want some transaction DTO object. If you create a new transaction DTO object, why I use the previous one is based upon our business logic. Focus on business logic here. If you use this statement, if you use this statement in the functional code, return me an object of transaction DTO, that is fine. We have two options. Either here we can create a new transaction DTO, or we can pass the previous one. Why did I use the previous one? Because look at the code here. In the code, the business logic is saying something like this. Okay, whatever response is coming back, on that response, we need to call get transaction reference and get transaction status. So get transaction reference, get transaction status is called. So if you create a new object, both of these two values will be null. So some testing is going to be cut down here. However, if you use this existing object, what is happening? Just observe. Whenever you call model mapper.map method, this object is going to be utilized. Guys, this is important. Please focus. So whenever you call this method, we are going to get the first object here. On this object, you are setting transaction status and transaction reference also. That means the previous object which was returned is already having transaction status and transaction reference valid values. Accordingly, if you return the same object here, when this method executes, it will get valid values, not null values. So the decision to use the previous object here, it was based upon the project situation. Okay, it was purely based upon the project situation that when we call this, we need previous object itself. If you create a new object, null values will come, your further flow will be different, but we want it differently. That is where we created like this. As a developer, you need to make these decisions. Okay, when to use a new, when to reuse the previous one, and your business logic should say that. If you return a new one here, basically both of these two values will be null. This will be created with set reference null, this also null. Final object is going to not have anything. So you're running the method, but your actual values are not coming properly. So you have to think about functionality also. And that is where, don't worry, once you understand how to do the basic things here, AI is going to do it for you. That is where, as a beginner, freshers were not able to wrap their brain around how we are supposed to do all these things. Earlier, people used to struggle to really verify and validate every cases. And then people were saying, anyways, functionally, it takes me 2 days. Now for doing all this unit testing, I need another 1 day, 2 day of time. And then juniors were basically saying, no, I don't want to do unit testing. Because first, they don't understand. Second, they are feeling they are doing more extra time because functionality was already done. So that is where lack of maturity was there for juniors. But with AI, it will become easy for you to decide how to write, how to verify. That's where AI is going to speed up the professional behavior of the developers. People were earlier avoiding things. With AI, they will do it more. So that is where AI is going to help the development. So we have to embrace AI. Okay, earlier there was pain in the system. With AI, it is going to be gone. Let's do the testing. So even if you're not able to make this decision of reusing or using a new one, you give it to AI. It will help you to think clearly. Okay, so that's what with practice. Otherwise, with practice only you can make these decisions. So you need to really understand the code. If you use a new object, both of these values will be null for you. So in that case, this object is not going to give back anything. Then what are you really going to verify? So we have to check on those things accordingly. Okay, fine. So chalo, this is done. Next, let's do some debugging. One more breakpoint flow we will run and see what happens. Earlier the code was breaking. Now we fixed it. Let's see how it goes. Okay, we go here, create transaction, get inside this. So model mapper, you get a DTO with all null values. This DTO is what? This DTO is this one, this object. We called this method, we should get this object. So we called this object back with no values. Next, on that object, we are setting two values. So observe. So earlier, okay, now we created these two values. Now we are setting those two values on the DTO. So just imagine this DTO is now having created also and payment transaction reference also. Which is this DTO? This DTO is nothing but what you have defined here. Java is object by reference. Same object which you have passed here is actually functionally getting these two values. Okay, now what are we doing? We are further going through the flow. Earlier, this mock method was returning null. Now we said give back an object. Okay, but which object? Observe this object, the object which has these two things. How did it give us this object? Because we have told that behavior here. Okay, whatever this object is there, return that object itself whenever we do this, because of object reference concept of core Java. If you create a new object, here basically again an empty object will be there with no values. But now we wanted to pass the same reference. So that is how the flow is working. Object referencing is happening here. Okay, fine. And then you go further. Then you go further. And then you're creating a response object. And for that, you're reading these two values from this response. So let's check it out. Null is definitely not coming. And what is the value here? Perfect. We got some valid values. We got some valid values. We got some reference and we got status. And then we return this back. Okay. So second part is completed. We are able to successfully call the method. And for calling it successfully, whatever data we had to arrange, we arranged it. Means every time different methods, you need to arrange different data. And what to arrange, that depends upon that business logic only. So call is done. But guys, the main thing is now starting. Okay. So picture abhi baki hai. Let's go. Okay. First we arranged. So you have to, what did you learn about arrange? Depending on your functionality, you have to arrange. So every time it is going to be different for every functionality. It completely depends. You need to read the functionality with breakpoint, accordingly do the fixing here. So different for every functionality. Perfect. Second, act. What did you learn about act? We need to call functional method and it should execute as expected end to end. Means null pointers and all that drama should not happen. So yes, we have done these 2 points. Now comes the main part of unit testing, which is verify or assert phase. Assert is nothing but verify. Now we have to verify. Okay, what is verification? Verification means after calling method, Did it work as expected? Okay, nothing but you are going to do comparison, expected versus actual. Assertion phase is nothing but you just have to do comparison. What did you expect and what actually happened? And both expected and actual should be the same. Okay, if your expectation and actual result is same, then we say unit test is successful. If expectation and actual result is failing, then we say unit test failed. This is what is the final and the important piece. Okay, how are we going to do that? Okay, let's just look at it. It's very straightforward and very interesting also. Okay, so let the thread go. Okay, currently it is saying everything is happy. So don't think everything is happy. Even though it is saying everything is good, point is this is blunder. You have not done any verification. This kind of a unit testing is waste. Without verification, there is no unit testing. If you are not able to verify your result, basically what you have done is just time pass. This does not mean anything. Even though this is saying everything is successful and green, no, your unit you have not done unit testing so far. You have only executed. Unit testing is nothing but code protects code, and that is only happening when this verification phase is in effect. You only arrange, you are never verifying. Without this, basically you have not done unit testing at all. It's useless. Okay, even if in future developers are changing your code, it's just going to be okay because nobody will know whether existing system is broken because you have not done verification. So this is the most important part. This is required so that you can do this. Now let's go to this part, assertions part. That is where the magic happens, and this is where code is protecting your functional code. Okay, protecting your functional code. Okay, now let's think about it. How you have to think when you are writing the verification part. Your expectation is when we call this create transaction, okay, your expectation was, forget about what is the business logic, think about functionality here, because you can do better verifications if you do proper functionality. What is your expectation? When we call create transaction method, you expect data to be saved in DB. We are anyways not going to verify the cross parts, other services. But what do you expect back? We expect a response to come. Looking at the code, we expect that, right? We expect a response to come, and response should be not null object. So what do you want? We expect response to come. Response should not be null. If null is coming, means it's a problem. Second, in the response, some transaction reference should be available. In response, some not null transaction reference should be available, and response should have a status. Response should have a status as created. This is what is our basic expectation. Okay, when we call this, we should save it in DB, but we cannot verify other classes. For DB testing, we will do it separately. So here we are focused only on payment service IMPL. So here our expectation is we should get a response back, and response should not be null, and it should give you two not null values, and the value of status should be created. If this is happening, we can say create transaction happened successfully. That is one part of this. So first, let's do this one part of verification. Okay, let's do this one part of verification. So we will go to our test class and let's write our expectation. We expect, first of all, this will run, let's say my response or transaction response, whatever you call it. Yesterday's demo, somebody was doing this, I think Sneha. Please focus on your naming conventions, everyone. Variable should be camel case, method name should be camel case, class names should be with capital always, packages should be always with small case, no underscore and all drama. Okay, so please be careful. Class names always like this, variable names camel case, method names camel case. This is important, very important. If you're doing this in the projects, basically during review time itself, they will say, Arey, first read what is coding conventions, code best coding practices, code naming conventions, and then code it. So you have to learn these basic things at least. Right from day one, we are doing it, but observe and learn from that. Okay, fine, chalo, let's continue further. So this is transaction response. We will fix it. What do we want? Okay, we want something like this. Assert. They have provided some methods for this. Assert not null transaction response. Okay, assert not null. Again, what is this? This is nothing but it's a static method defined in a JUnit assertion class. So these are all methods which are defined. Okay, assert not null. These are all methods which are defined where they are writing some verification logic. Okay, so we are saying this value should not be null. How do you say that? Assert not null method you call pass the value. Second, we are saying, okay, assert not null, reference also should not be null. Assert not null assert not null, status should not be null. Okay, redirection URL should not be there. Just know that in this object there is a redirection URL also. What do you expect with redirection URL? Redirection URL should be null. During creation time, redirection URL is required. So assert null. I want null in response.get redirection URL. So whatever you want the behavior of the system, you need to protect it. And that is what is the assert phase. Whatever you want the behavior, you have to protect it. That is the assert phase. So I want a not null object should come in which transaction reference should be there, transaction status should be there, and redirection URL basically should be like a null value or an empty value. You define whether null or empty, check whatever you have done it in the code. Okay, next. So for us, I think it's null, so we will put it null. This is fine. Next, let's test it first of all. We go here. No need to verify each of this piece. Let's put up a breakpoint here. Run it back again. Okay, we got a response. The response is available with these three things. Perfect. So assert not null. Perfect. That is not null. If null would have come, here our test case would have failed. Okay, no, it's not working. Test case is failed. Next, transaction reference should also not be null. Yes, it is also not null. Transaction status should also not be null. Okay, it is also not null. If there is problem here, if anything comes null, test case is going to fail. And the second thing, redirection URL should definitely be null in this case. So definitely null. Everything is fine. Let's go. Now we can say at least some basic assertions are there. So to some extent, we have taken care to verify how the method is behaving. Okay, let's say in future. Now we want to add more checks. What are the more checks? Now think as a developer, how much you want to protect this. Okay, so let's think about it like this. Status, we want that created should come. So we will be writing it like this now. Assert equals, perfect. Status is supposed to be created. Now more control is coming. Okay. Next, you know that transaction reference is a UUID. Okay. So let's check it out. ChatGPT. UUID. What is length of UUID string? 36 character. So now you can think about more creative ways of checking. In future, let's say somebody changes the logic and UUID becomes different. We want to even capture that, because when in 2025 we developed it, we want that it has to be UUID only. So our logic is going to verify assert equals. Perfect. AI is so intelligent here. Are you getting it? It's as if it listened to what we wanted to type, but it is smart enough to understand that is a logical thing to do. Length is 36. That means in future, even after 20 years from now, if this project is running, somebody changes the UUID, either makes it smaller or bigger, this test case will fail and it is going to be a warning for them. Okay, let's try to understand why this warning is important. But first we will test this. Okay, so we will go here. We will run this back again. Now this is how you do more checking about multiple scenarios. All this so far we already verified. Now these two things. Okay, your transaction status should be created. So fine, this is created. And the length of the transaction reference should be 36 because UUID logic is 36. So yeah, it is all fine. Okay, what does this mean? If in future any developer does a mistake and makes any changes which is not compatible with this, our test case will fail. That's what this means. 2025, when we build this system, this is our base assumptions. It should give a null redirection URL. It should give this, and the status should be created. Now let's assume in future, somebody says, instead of created, I will make it initiated. Whatever requirement might have changed. Okay, you will run your test case. And the test case is going to fail in future. So just imagine, fast forward, after 1 year, somebody came and modified here, initiated. Maybe intentionally, maybe accidentally. But our test case, which we have written today, is going to run at that time also when Maven package happens. And then test case is going to say, hey, I was expecting created. You are returning me initiated. Something is wrong here. Please check. Your build is going to fail. Your jar file will not happen. You will realize, oh, some other developers expected it to be created at that time. Okay. Accordingly, let's assume similarly, then you will realize, oh, so by mistake I did it. I have to make it back to created, let's say. And then people will run the code again. And then they will realize, okay, fine. So now it is coming okay. So then they will know, oh, we have broken the system. We changed something, we have broken the system. Similarly, if these people in future decide, okay, along with UUID, give some, let's say, double, just for testing purpose. So that means it's a violation. The logic which is defined as of today, somebody is changing it. So our system should track whenever that is happening. If old system behavior is changed, our system should catch those things. So we have put some preventions checks there. It is saying, come on, expected was 36 length. Now all of a sudden your length is grown. Then you will realize, oh, okay, so we should have UUID only. This is by mistake. Then you will change it back to normal. And then you will fix it. So please note, whenever your test cases are failing, it doesn't mean just go and do like, okay, basic thing is whenever test cases fail, you need to think, what is the problem here? Just going there and changing, okay, now let me expect 72 is not the fix. Guys, please understand. Here, let's say you have added this, and immature junior developers will generally do this. They will be like, oh, test case is broken. Without thinking, they will go here and they will say, okay, now I should expect 72 because now new requirement. If you have done this, it's a blunder. It's like unit testing told you that something is broken and you were so dumb that you did not fix it and you just came and just updated the test case. That's a problem. Please understand. Okay, now this is going to work. Immature developer will just do this. Carry test case is failing, let me go and update it 72. Arey, no, you caused bigger problem. You have hidden the problem here basically. Fixing unit testing does not mean go and just fix it. Let's say in future, you are actually hiding the problem now. You are even doing bigger damage in the system. Unit testing was there to tell you that there is a problem. What you have done is, let's say as a developer, you updated this as initiated, and this was not supposed to be the case. And when you did a package, the system of the past, developed 2 years ago, told you, okay, here we wanted created, but you are giving us initiated. Immature developer will just update this as initiated, saying, "Arey, test case anyways I have to pass, let me mark it as initiated." They will run this and it will work. But this is blunder. Unit testing told you, okay, you have broken the system, and now you are telling unit testing, no, everything is okay, let's go. No, it's not okay. You have to think deeper here. More maturity is required. You need to understand it something like this. Let's say, for example, let me give you an example, you will get it more clearly. Validation service is going to call processing service. This is your API call. In response, you are going to give back transaction reference, and you're going to give back created status. This is what is the today's agreement. What does this mean? Validation service is going to write the business logic at their side accordingly in their service, which is somebody else in future. They will go to the database, and what if they create a DB table with length of transaction reference as 36 column? They can do that because right now you said we are giving you transaction reference, which is UUID, which will be length 36. They designed their database table with value 36. And you said, we will give you back status as created. Now they have written their logic. If status dot equals created, then you are supposed to process it like successful. Else everything is a failure. Now, this is where unit testing is actually required. Now, what is happening as of today? This was the agreement they coded and the system works. Now, in future, as a developer, you are making modifications to these agreements. You are saying, I will not give you created, I am going to give you initiated. And then there is this unit testing which tells you, hey, no, I want created only here. Why this is so important is because validation service might have written logic based upon created. So fixing this unit testing to initiated is not solving your problem. Please understand. Even though when this code goes to the production, validation service will break, and it will be because developer were immature. They did not really understand. Unit testing told them that it is a problem, and developer simply overlooked it, fixed it with 72 and like this, and caused a problem. And when this 72 length actually goes back here, it is going to fail in the DB insertion. Means unit testing is trying to tell you that you have broken system, but you are closing your eyes and you are saying, no, I want to still continue with my wrong code only. And then if you do this, handle it like this, it goes to production, it fails, entire unit testing effort is wasted. So please understand, unit testing is code protects the code. But for that, you need to have maturity about unit testing. You need to verify the cases properly. Okay. Second thing, if your test cases are failing, you are not supposed to immediately act. You are not supposed to just go and change this system or go and change this system. No. Whenever your test case is failing, you're supposed to think, what has gone wrong? Why was the existing system expecting something else? And you should know that if you are changing this test case, maybe there are some other systems like validation service which will still be working. So you have to investigate to that level, okay, who are the consumer of this service, and you need to tell if your change is valid. Let's say you are saying going forward we will be returning only initiated. Requirements might change, so you might have to do this initiated, but you need to first analyze who are using your service. And then you need to tell those all people, okay, earlier we were giving you created. Now, from next release onwards, it is going to be initiated because this is a new change in requirement from our side. Please accordingly update it at your side also. And then with coordination, first you will get that agreement. After that only you should change this status to initiated, then it is valid. But if you don't do this communication, don't do this analysis about what is happening to rest of the systems and directly fix it here, you are still, after doing unit testing also, you have still failed the system. Your unit testing is useless. Unit testing told you that there is a problem and you are like, I don't care. Everything is done and everything is useless. So you need maturity to deal with unit testing. Step 1 and step 2 is only arranging the thing, but the heart of unit testing is this. What all you verify, and when this verification fails today and in future, imagine you are new to a project and some other developer has written all these test cases. When you are making changes, if you have broken it, it is your responsibility to really investigate what is broken. Don't fix anything, investigate first. Whatever you are changing, new code, is that expected? And then you have to tell to your product owner, okay, in the past, this system was behaving like this. Now you are asking us to change it. Maybe they also don't know that. They will be like, no, we are not supposed to do that change. So then some other requirement will be further updated. But unit testing is to protect your system. But as a developer, you need to have maturity. Okay, when it tells you something is broken, you think, you analyze, and then you decide how you want to fix it. Maybe functional change will be there or unit testing change will be there. It could be anywhere. But before that analysis phase happens, you have to really see where the problem is, what the impact is, and what the fix should be. So that kind of discussion is supposed to happen with the team whenever something is breaking. Okay? Because old system expected something else, you are doing something else. So our old system wants that it should be created, so it should be created only. It wants it to be 36, so it should be 36 only. If you are changing this, you need to check it out with the invoker users and then work with them to first fix it. After that comes your test case fixing part. So unit testing raises the alarm to you. But if you overlook it, means still the developer has caused problem in the system. Guys, did you get it? It's important to understand this. It's very important, guys. Okay, generally as a junior, we feel it's more of just syntax and assertions. No, there is a deeper meaning to that. If you don't catch it now, problems will come. Even after implementing everything, it will be waste of efforts if you don't get the maturity how to deal with unit testing. So let me write down step by step how you are supposed to think, and that will help you definitely. Okay, chalo guys. First, you have to learn all the syntactical and other part, but there is a deeper meaning. Okay, what is that? What is that? Okay, when you have new functional changes, okay, apply it in code. Okay, that is fine. Second, always run existing unit test cases. Always make it a habit. Okay. Next, whenever a test case fails, don't fix it immediately. Okay. First, investigate what has gone wrong. Investigate what has gone wrong. Okay, what does this mean? Is this a problem in your new functional code? It could be a problem in your new functional code. Or is this a new requirement change? Or is this a new requirement change? It could be anything. Okay, if it is a problem in the functional code, you need to fix it. You need to fix the problem in your code. Functionality has to change there. Next, if it is a change in requirement, then you need to investigate the impact of this change. Okay, because existing system was expecting different. Okay, once you investigate the impact, handle the impact. Maybe you need to call to other people, discuss with other people, manual coordination will be there. Handle the impact, discuss with other guys for solutions. Okay, check who all are using this feature. Okay, and ensure the new change is also accepted by those users. You need to do that. Once that is done, then you change the unit testing assertions. So you don't directly change the unit testing assertions. You know, 36 should now become 76. 32 should become 76. No, you don't change that. First, you do this. You discuss with the other people. Hey, we are planning to change the UUID length. The transaction reference is not going to be 32 anymore. It is going, what is that? 36, right? It's not going to be 36 anymore. It is going to be 72 going forward. Then you need to check with them. Are they okay with that kind of change? If they are saying, no, we need to update our database size. So first you need to work with them. Okay, they do it properly. Then you come to your unit testing to change it to 72 once you have resolved that. So this is going to be your simple approach. So you might have to fix your code, or you might have to fix test case. But if you want to fix your code, yes, you can straight away do that. Make sure old system is working. Don't change the old test case. Just fix your code. Make sure your changes work. Old system is working. Second, if you have new requirement, means you want to change it to 72, no, fine, it could be, right? In that case, you have to investigate. You need to first get it fixed. After that, you have to do the unit testing change. And then you again, yes, do the package and then continue with your deployment. This is your approach required. Okay, fine. So there you go, guys. We tried to do some unit testing for us. Some kind of verifications we tried to do. Okay. Now there is the third concept which comes in. Code coverage. Code coverage. Okay. Now, before going to code coverage, let's do one more thing. We tried to provide some kind of checks. Okay, it should be like this. Let's run it once more. Let's run it once more. If you have broken the system, yes, we know it has broken. Where it is broken, oh, created, and here actually initiated is coming. So we have to first fix that. So that is what we will know, that system is broken. So here created status should be going. Next, even UUID we have broken. Generate UUID. So we need to fix this also. So functionality, we broke it, so we will fix it. Again, run the test case. It says, okay, everything is fine. Now you can rely that, yes, it is fine because everything is done properly. Now, dekho, you can do more verifications here. That is where ChatGPT and the intelligence of ChatGPT will come in. Let's say if you are not able to figure out to what extent you have to verify all this, ChatGPT will come to your rescue there. Okay. Now you take this functionality. Let's say you did this created, right? You take this functionality and go to ChatGPT and you give it, below is my functional method and I am doing unit testing. Okay, ensure the functional method is strongly verified so it doesn't break in future. So this is your functional method. Give your functional method. Next, give your test method also. Give your test method also. Okay, and say, give me all other verifications that I should use. Verifications, assertions that I should use. Okay, let's see. Good job. It covers the happy path. You have done not null and all those things. Very good. This makes it future proof and strongly verified. So what we did is a good work so far. But still, AI is having intelligence. It has studied a lot of project code. Now it can suggest us, okay, still suggesting something. Okay, instead of just checking the length, you can ensure that when you call this, it should not throw an exception. Okay, maybe there could be a possibility in future this method might throw an exception. So this guy is saying, okay, so maybe you can do like this. Okay, next, status enums, some array check it is suggesting. Deep DTO verification, it is suggesting that maybe some DTO values also you check. Currently we have not checked the DTO values. When the method is executing, it is updating the DTO also inside, right? It is updating the DTO also. So it is suggesting maybe DTO verification also you should do. Next, mock verification. Verify, okay, model mapper is called how many number of times? So much of control. Verify, model mapper is called one time. Next, verify, payment service is called one time. Just imagine, ensure no extra interactions. Verify, no more interactions of these two things. Now what is going to happen? It is covering so many cases. Okay, next, if input request is given a null value, then there could be some other problems. Illegal argument exception. We need to see whether this kind of handling is there. Okay, but just observe, it has provided us multiple other suggestions. Now, one by one, we can check on these and try to apply it in the code. Okay, so let's try to do this. So we can go here, assert does not throw exception. Let's see, one by one now we have to investigate. And we have to understand what these checks are. Okay, Control-Shift-O. So when your transaction reference, it has to be a UUID. Whoa, they have provided another method, UUID.fromString, which is going to make sure that response is always a UUID. So not just length check. There is another method in UUID which checks whether the value is a UUID only or not. If there is a problem, it is going to throw an exception. So in future, you give something else, change the UUID logic, this assertion will fail. That's wonderful. Okay, so we go here, we save it. So this is how AI can further help you to cover more detailed cases. We took care of length, but now just see, in future, logic is changed, this will fail here. Okay, next. Okay, some enum values. Ensured status, return status is valid. Let's try to put this assert true from the enum, one of the status values coming from enum. This is what they are trying to test here. Okay, Control-Shift-O, arrays. Okay, basically it's just a check. Here we did hard coding, created, but instead of that, we check whether that value belongs into a valid payment transaction status. AI is thinking very deeply now. Rather than just doing at string level, it is trying to further check the value which came is a valid transaction status reserved in your system enum. That is good. It is deeper. Now this becomes your verification steps. This has to be, you have to put your brain into how this part will be. Arranging the data, you will do it. This is where intelligence is going to be required. Because if anything in future, you return a status which does not belong here, you change the UUID, you change the length, everything is going to start collapsing. Currently, this is good. Next, you go forward. Okay, check whether the value of these two DTO is also correct. As maximum as you can, you put those many checks here because everything protects your system. Okay, put it. Let's run it back again. Super. Everything is working fine. If there is any issue anywhere, if this DTO value is not created, it is going to fail. If transaction reference gives you a null, it is going to fail. Okay, there are problems everywhere. Let's say, for example, in future, some developer comes here and developer says, oh, by mistake, I commented this transaction reference. By mistake, developer did that. Okay, and your system, which is coded earlier, it is identifying it. The previous system identified it. Okay, in transaction response also it did not come. So it will fail here also, it has failed here also. So you need to protect your system. Every single thing, the more deeper you write the verification part, the better control your system is going to have. So this is where intelligence is required. Remaining thing is just semantics, you just have to call it, but the brain of unit testing is verification. How strongly you can verify, how deeper you can verify, that much system is protected. That's awesome. Okay, so using ChatGPT, now you can do verification of everything. Okay, you can get very deeper. Otherwise, it was not possible. Developers were missing so many cases without AI. Now, yes, you can do very deeper concept. Not just here. ये और भी बोलता है. Make sure model mapper is called one time. Okay, we will do this verification also. Okay, if 2 times you are calling model mapper, it's going to be a problem also. Okay, model mapper is called only once. Whatever your functionality is there, accordingly this guy is checking. So model mapper, it should be called only one time. That's the verification. Very good. Next, payment service is also called only one time. So all these are checks. In future, if developer starts calling it 2 times, okay, this test cases will start failing. Then developer has to use, oh, this guy has written it should be called only once. Why am I doing 2 times? Is that a functional requirement or is this test case a problem? Then he will say, oh, this is a functional requirement. And is there any impact on anybody if I call 2 times? You need to ask yourself a question. If there is impact, solve that. No impact. Okay, come here to verification and say it should be now 2 times. This is how your handling should be. But yeah, this is deeper. Okay, ensure no more extra interactions. Means model mapper and this is done only this much time. Okay, so ensure no more interactions. Okay, Control Shift O. Many verification things are there one by one, but you need to know what that is. Don't blindly rely on AI. Understand it. What does that mean? And then just imagine if any of this verification fails, blunder in the system. Okay, and then some negative case, you call null and then it should return like this. But we don't know whether our code has done that. So we need to really check this thing. Okay, should throw exception. Let's see. Fine, that's it. So we need to take care. I think this is really good example in front of you. So much deeper verification. I will give you all this code, right? By the end of this week, I will share this thing with you. But using AI, you can do far better verifications. Any kind of method. Method which is not returning any return type also, void methods. When I was a fresher, I used to be like, if return type is not going to be there, void, how do we verify? Okay, these all verifications will be there. Whether your method is throwing exception, not throwing exception, by object reference is going to be passed inside. So you can verify whether the reference data is coming properly or not. You can verify how many times the mocks were called. So void return types can be verified in this manner. So using AI, you can understand what is the best way for verifying every possibility, but you have to use AI smartly there. Okay, guys, are we clear with this? Verification is the heart of unit testing. Remaining things takes you to that verification part. Verification is magic. That is where everything is going to come to picture. Okay, guys, are we clear with this team? Are we clear, guys? Give a quick thumbs up. And generally, as a fresher, it takes few years for people to really understand this. जल्दी नहीं समझता है. They are like, हाँ चलो लिख लेते हैं. It needs actual solid 2 to 3 years to understand the value of unit testing. 2 to 3 years of working experience, then people understand the power of unit testing. After that, they will say, without unit testing, I am not going to do coding also. Okay, and that is where these concepts are there in the market. Test-driven development means you will do unit testing and parallelly you will do coding, not like both are separate. So sometimes then people will go, once they fully understand the power of unit testing, then they will do TDD, test-driven development. Nothing but first you will write unit testing and then parallelly you will do that. For that, again, you need to understand value of unit testing first. Okay, so test-driven development. Okay, fine. Hello, let's go to the last part, which is code coverage. Okay, this is the last part, code coverage. It is very simple. Code coverage. Let's say your manager is telling you unit testing is very important, you have to do that and other things. And yes, as a developer, you want to take shortcut. Okay, and you are like, ah, kar liya, dekho, I have done my unit testing, so many cases I verified. Okay, and manager will be like, very nice, you have gone very detailed. Immediately manager will ask you a question, how much code coverage do you have? They will use these numbers. Okay, what does that code coverage mean? Let me show it to you here. If you do right click, I'm getting another option, coverage as, that is code coverage. Okay, there are other plugins and multiple ways of doing it. I'm showing you one of the way. Coverage as, you do unit testing here. Run as, debug as, now coverage as. Okay, wait for some time. Okay, just observe. It highlighted the code which executed during this unit testing. Code coverage means it checks how much of the code actually is covered in unit testing. Okay, so it highlighted this in a green color, means you have executed all this. Important thing is, go to the act phase inside create transaction. Look here. It is telling very clearly, this create transaction, each and every line is covered by unit testing. Okay, this generate line is also executed by your unit testing. However, as soon as you go to this initiate block, it is saying there is no unit testing written for this initiate block. So code coverage is going to identify how much of the code is actually covered in unit testing. You cannot simply tell to the manager, yes, I have written unit testing. Manager will be like, tell me the code coverage. And now code coverage is showing that, oh, you have done it only to one of the method. The other big business method, initiate, is still pending. Okay, that is how code coverage will be there. And the manager is not going to look at each and every file. The manager will say, okay, can you show me in terms of percentage? And just observe here. In our entire processing service, in SRC main, only 6.4% code coverage is available. 6.4%. Okay, basically you will ignore POJO classes and all the other, only the business classes you will be considering. Okay, you will consider the business classes where actual functionality is there. For example, this is the actual functionality. Just see, payment service IMPL, here we have done the actual functionality. So it is giving a clear-cut percentage that in your SRC main Java, currently only 6.4% is unit tested. Next, in your payment service IMPL, 33% is unit tested, remaining 70% is not unit tested. So your manager will be, array, complete the unit testing for the remaining blocks. That is where code coverage is important. It is going to make sure that accidentally you are not missing any cases from covering it. For example, here you just missed a method. Code coverage is going to tell you that you have not done that. Okay. So always code coverage in terms of percentage will be there. And people will say minimum 80% coverage should be there. They will set up tools. Okay, if your code coverage is less than 80%, your code review is not going to happen. They will simply reject your code review also and say, okay, first go fix your unit testing so that coverage is coming like 80%. Means you need to write more test cases here to cover more scenarios so that it crosses 80% for you. Okay, so like this, code coverage is going to be useful. How do you get this code coverage? You need to install a plugin for that. So this is one of the way. There is another Jacoco plugin also. Using that, you can configure it in your pom.xml, and whenever you do a package, it will be running and identifying your code coverage. It will give you a nice report. So Jacoco plugin is one of that. One of the inbuilt Eclipse tool I am using, which is, if you go to help Eclipse Marketplace, okay, Eclipse Marketplace, just search here for code coverage. Using that, you can apply it the way we say, run as, debug as, coverage as. You just need to install this code coverage. Yeah, this kind of ECL EMA Java code coverage. So search for this and install it. It's already installed in my machine. After that, maybe you have to restart your Eclipse once. Already in the documentation here, the notes which I'm going to share, I've taken a screenshot about this as well. So you can simply install it from that place, and then you will start getting this kind of an option. Okay, you will start getting this kind of an option. You can check it in my installed location. Already this is installed, plus at the same time, Copilot for Eclipse. This is another software which I have installed from Eclipse Marketplace itself. So you need to open an GitHub Copilot account first. That will give you some unique ID. And then you have to even install this one and link that ID here so that you can use Copilot for Eclipse, and that will keep giving you suggestions. This symbol is nothing but Copilot for Eclipse symbol only. Okay, fine. So now this is required. Okay, so this tells you basically code coverage. Now let's look at this one more thing. If this color is annoying you, how do you remove that? Some people might have this doubt. So you simply click here and just click this, remove all sessions. So basically color will go and all this tracking is also going to disappear. Otherwise that color shade will be there. Okay, now let's just look at magic, the magic of AI. We learned so many things. Okay, from the beginning of today's session, we learned so many things. Let's say you already knew how to do all these things. You know the basic annotations, and you know how to write it, the value of assertions, everything. Now, let's say you're new to the project. You have a new functionality. Okay, what I will do is, I will directly go to ChatGPT. Okay, I will take this functional class. If you know already all these things, then it is easy. I will directly take the functional class and I will go to ChatGPT and say, below is my Java functional class. Okay, and then I'm going to ask, write me JUnit, okay, test cases using mocking, okay, which covers each and every possibility of code. I want maximum code coverage which handles everything. Okay, another thing, there are multiple ways of doing unit testing. Okay, there are different other annotations and other styles also. You give your style to ChatGPT. you say, okay, I am doing unit testing using below, try to give everything in similar manner, and give some examples of how you are doing unit testing. Okay, give some examples of how you do your unit testing. Give some examples of maybe these when-thens which you have. Give some examples of how you are doing these assertions and verifications. Okay, and then put it here. Write complete test class. Let's see. Okay, now this guy is busy. What would have actually taken easily one day for all the junior people, now just observe. Within 2 minutes, 3 minutes, fatafat, this guy is just writing all the cases. And almost it is going to work. Maybe small modifications here and there could be there, but majorly it is going to work. 95% of your work will be done here. You have to make sure you understand all that. Okay, you have to make sure you understand all that. And yes, we understand. What's the big deal here? Observe. Okay, extending, that is fine. Next, mocking, that is also fine. Multiple mocks are there. Injections, you understand injections also. Okay, it is doing a setup before each. Means before every test method is executed, always do this kind of initialization. So it is grouping because it is going to write multiple methods. So some common initialization it is doing before every execution. And then it has written multiple test cases. So we can understand that. Next, we know these things when then kind of statements used for setting the value. We call the business logic and we are doing good amount of assertions. Good amount of assertions. Next, we go for initiate, multiple scenarios. Initiate happy path. Initiate when processing exception is thrown. So handle both the scenarios. How do you take care of the happy path scenario? Okay, whatever data is required for that, this guy is arranging it. Whatever data is required for that, arranging it. Then it is calling act phase, and then it is verifying. Observe everything, verification to very great details. This is the actual act part, and this is where the arrange part to achieve the requirements. And likewise, you go to the third case, exception thrown case. Here it is saying, okay, when you call this, basically some exception assert throws is available. It is saying processing exception should be thrown when you call this. And accordingly, some handling for that. This guy is also trying to verify whether everything is coming fine. What basically will take easily one day can be done in few minutes. Now, because you understand basics of unit testing, then only this power is useful to you. Otherwise, you will be like, not sure, chal to raha hai, but I don't know what is happening. Fine. Let's try to just take this up. What we will do, we will not disturb our current class. Let's create a new class here, V2 version or AI. Let's say test AI. And in this one, we will simply be applying all this code which this guy has provided. Copy everything. Just name this class as AI. Save it. Control-Shift-O. Okay. Only 2 errors are there in this class. Let's understand what these errors are. HTTP request. It is doing HTTP request using a new operator. Okay. Here also HTTP. Here, what is the second problem? So here problem is new operator. We created HTTP request with builder. So new does not work. We need to have a builder. So we have to make that change. It does not know that we have used a builder. That is where it used a new operator. Okay, fine. Next, what is the problem here? processing exception. Okay, what is the nature of processing exception? It expects three things. So wherever AI did not know the full structure, it made assumptions. So here HTTP status is also required. So fine, let's fix it. Let's say HTTP status dot, let's say internal server error. We need to see what this logic is basically. Okay, so let's check it out. Stripe down, failed, blah, blah, blah. So we have fixed one of the error. We need to fix this another one, which is use a builder design pattern. Okay, how do you use a builder design pattern? Response entity dot builder dot build control shift. Here this is not going to come. Control shift O. HTTP request dot. Okay, fine. Everything is saved. We can get into one by one details, but let's just try to check it out here. So it has return control O, three methods. One setup method is there, create, test, test. Three methods, fine. Let's run it. Okay. This guy has not added any loggers. This guy has not added any loggers. So debugging wise, we will not be able to check it out. But anyways, right click, run as unit test. Perfect. We did not do anything. What a developer will need one day, we finished within 10 minutes. That's the power of AI. And you have to use it. There are many people who will have other views, but no, look at this. Okay, now let's look at the second thing. We asked it to cover every case. Maybe it did. So many assertions this guy has added here, verifications and all these things. Okay, now let's do this scenario. Right click, debug as JUnit test. Oh, not debug as. Not this. Coverage as we want to do. Coverage as. Right click, coverage as JUnit test. Observe. Let's see how much of code this guy has covered. Okay, so this code is fine. Let's go to that actual functional class, which is this class. First method fully covered. This is covered. Initiate transaction covered. Try block covered. Exception block covered. Pending scenario covered. Everything is covered. So power of AI, right? Now you go here. You go back to this console. Check it out. What has happened to your class? Payment service IMPL, 100% covered. Right? By this way, you should try to cover all the possible cases and use AI. So it is going to really help you to maturely understand and handle each and every possible scenario. But main thing is, remember the strategy of fixing. It's not about just randomly fixing it. You need to have a thinking approach when you're fixing it. And guys, if you are already working somewhere, if in your project unit testing discipline is not there, so you take that initiative and say, going forward, I am always going to write unit testing, because with AI, it doesn't need time also. Maybe within 1 additional hour for all your feature, you can build unit testing just like that. So don't push it. And power is very important. One time you write it, forever you can enjoy this for the next 10 years. So it is very powerful. Okay. So it is very powerful basically. So try to do it properly. Okay. And therefore, there is this one thing. I don't know, but some of the people, I think majority mindset has already changed. Like, we want AI, we want to use AI for development. I don't know. Some of the people might still be thinking, okay, no, why is AI here? I still want to do like coding and all those things. AI is affecting the jobs. No. Still, some people might think like that. But guys, it is very simple. Some people might even have this kind of memes are created. If a person using ChatGPT, how the mind is developed versus somebody not using ChatGPT, how their mind is developed, right? And generally, again, juniors, since maturity is less, so they will feel like, yeah, so I should not use AI because then my skills will reduce. Fine, one side of logical argument is there, but you need to understand this conceptual thing here. Okay, let's say you are going from one city to another, 300 kilometers you want to go. right? One way is you start running, you start cycling. Another way is you get a bike or a car or some transport and go via that approach. Now, you can have this argument, no, but I want to run and go by cycle there because that makes me healthy. My bodical physique is going to be great. But now you are very smart enough to understand, if you run, yes, physically you might be great, but wear and tear will happen physically and it will take you long time. So the smart move is to take a vehicle and then go. Same thing is with AI. AI is going to take you 10 times faster. You are saying, no, I don't want to go 10 times faster. I want to work and then as hard as running on the ground, making my muscles. No, guys, exercise is a different thing. If you want to work on your muscles, exercise different thing. So AI usage or not, that does not define whether you're growing or not mentally. Mental growth is a separate game altogether. The way you go to gym for exercise, like that for mental growth, yes, use AI, but grow in your thinking mentally. How to use AI, go your design thinking. Mental growth will be still a different activity to be done. So don't get into this, no, I don't want to use AI, and if I use AI, my growth will not happen. No, that is purely nonsense. It is irrelevant. Both are two different things. You want mental growth, yes, you have to do more logical thinking, more problem solving, more see the exception, do more reading. Automatically mental growth will happen. And then use AI so that you can not run there but drive there and reach there easily, right? The person who is driving, it will be there within one day there, and the rest of the guys might take a month to really come there, right? So you can imagine the difference between success and failure. So don't reject AI, don't fight AI, because it is anyways there and it is going to be utilized whether you like it or not. The sooner you adapt, smarter you will become. But yes, mental exercises, you have to do that. So logical thinking, problem solving, you need to keep doing those things, and that is where you will be more efficient with using AI. Okay? So fine, guys, everything. Is this all clear, guys? So today you need to do all this. Maza aega. Build your own unit testing. Tomorrow we will connect for the final day of our official sessions. Pending topics, we will arrange some topics next week randomly, but tomorrow we will have the final day. Let me just share you with the quick plan. What are the things we are supposed to do? Okay. So tomorrow is the last day, week number 8, day number 5. As part of this, we have some topics planned like functional use case discussion about ActiveMQ, Redis, and recon service, functional discussions, plus end-to-end working process from how QA, UAT, production process is going to happen, bug fixing is going to happen. That end-to-end process we will be discussing. Okay. So these two things are very important. So that is the plan for this topic. And then accordingly, tomorrow, end of the day, tomorrow EOD, you are supposed to complete total of 5 or 7 demos. Many of the people have already crossed this number. Okay, whatever. So tomorrow, end of the day, 26th of September, you complete this. Okay, after that, on 27th and 28th of September, we will issue the completion letter, whoever has met this 5 to 7 demos. The first batch of completion letter we will issue on 27th, nothing but Saturday morning. So everyone who submits it by 26 September, on Saturday morning, completion letter will be issued. Second, we will issue on 28th September, Sunday evening. So some of the members have actually requested, okay, we will complete it by this weekend. So fine. So Sunday evening, so we will send second batch. If on Saturday, Sunday, you complete your 5 demos, 7 demos, Sunday evening, you will be getting the completion letter. If you do it next week, okay, let's say 29th or 30, so 30 of September, then your completion letter will be issued on that upcoming weekend. Mostly it is going to happen on 5th of September, October. Every weekend, Saturday or Sunday, someday, it is going to be there. So that is where every weekend by weekend, we will keep issuing you. So try that in the month of October, you complete it. in October you complete your demos. Try for that part. Okay, so fine, this is what is required. Other than this, we still have few more sessions to complete, technical sessions. That, okay, for that attendance is not going to be tracked, it will be ad hoc sessions. We will do those ad hoc additional sessions next week. Whether you are joining live or not, recording will be available, it will be updated in our notes. Major topics that we want to do. Okay, first of all, we need to complete logging, SLF4J and all that. Important topic hai, technical, we have to do that. Second, we need to work with Eureka server and service registry. Okay, Eureka server, Eureka client, of how to make that call, that we will do. Plus, along with that, circuit breaker. This is also a microservice related topic. So these two additional things we have to still do. So we will arrange some 2 sessions next week sometime, maybe 10 a.m., maybe in the evening, and then we will do this. Recording will be available. Okay. Other than that, some revision sessions we started. Yesterday, there was one revision. Yesterday evening, 7 to 9, we completed one revision. Okay. Today, there is revision number 2. Today, revision number 2, 7 to 9. The team has done really good work there. They were live coding, live explaining, live setting up. So means confidence on their hands-on knowledge, it was reflected. So means some of the guys have really worked really nicely. So revision 2 topic is going to be there today. 2 more revisions will happen. One will happen on Monday, 10 a.m. Revision session Monday, 10 a.m. Next Tuesday, 4th revision session will be there. So revision will be on Monday. And 4 will be on Tuesday, 10 a.m. So again, recording will be available, if not live, wherever. But revise it. The more you do, better knowledge will come. Apart from this thing, on this Sunday, we are doing one AI topic. Sunday, 10 a.m. So it's a busy schedule, basically. Okay. So the number of sessions, if you really want to put in. Sunday, we are going to do AI LLM internal topic. Okay. So that's very important. Every developer should grow towards becoming an AI engineer. It will give you more options in the market, and future is anyways more going towards AI. So we don't know right now to what extent day-to-day functional development project will be affected, but always good to have AI engineering knowledge. So you will have both areas to make it in your career. This AI internals topic is going to be useful for that LLM internal understanding. Lot of internal concepts are there. It's not just about using Spring AI to achieve a LLM that we have already covered earlier, but here we are going to discuss about LLM internals, which means we will be understanding how LLM transformers are internally working, how it generates using self-attention mechanism. These are all internal concepts. How neural network operate internally. What is this concept of token, matrices, some mathematical aspects with how LLMs work. We will be checking on those areas. Next, how GPT's kind of tool, generative tool, okay, predicts the next output. So when you're talking to Chat GPT and all, how is this intelligence actually working? When you ask a question, how it gives you back end-to-end process understanding. That is what is understanding the internals of LLM. So this one topic will be there, 3 to 4 hours, big topic. But yes, plan is on Sunday. So basically, it's going to be very busy. First of all, 25th of September, 10 a.m., we completed our live done. Next, we will be connecting 25 of September, evening, 7 p.m., we will have revision topic 2. Okay. After that, tomorrow, 26th September, morning 10 a.m., we will have week 8, day number 5. Okay. After that, on weekend, completion letter will be issued. And after that, on Sunday, 28th of September, 10 a.m., AI internal topic will be there. LLM internal topic will be there. After that, on Monday, 29th of September, again, 10 a.m. we will have revision topic 3, and after that on Tuesday, which is 30th of September, 10 a.m. we will have revision topic 4. And after this, we need to arrange 2 more sessions for additional topics, which is going to be this logging topic and Eureka plus service circuit breaker topic. So those things, when it will happen, we will decide that. Maybe Wednesday itself, we might do one in the morning, one in the evening, or wherever. But next week itself, this is going to complete. That is for sure. Okay. So a lot of busy days are there, morning, evening, weekend, everything is occupied, but fine. So try to take value out of all of these things. Okay. So guys, good stuff, everyone. Let's take the attendance and complete today's session. Practice is key. Yesterday, the members did really good job. Okay. So I think the team 1 members, Anuj, Vartika, Sneha, and Farooq, these 4 members, they did practical setups and other thing. So whether you have seen it or not, I think watch the recordings. So it will act like nice inspiration for you, because they also started with you, but now have very nice grip on each of the topics. And I think more and more revisions will help us further. Okay. So good to see the growth. So let's take the attendance, guys. Okay. Attendance code for today is 1111. And let's complete the call. Okay, guys, code for today is 1111, and here is the link. Thank you, everybody, on the recordings. I'm stopping the streaming. Okay, chalo, guys, see you today evening 8 p.m. Stop stream.